support. And so wrote a letter of support. And I think the next day, Dobbin back channeled me and said, hey, you guys want to be a little bit more involved than just a letter? And I was like, yeah, absolutely we do. And so he gave me this big homework assignment like 2 days before I had to leave for Christmas break. And I was like, I will try my best. And the rest is history. But we appreciate that local contact and really for the last 3 years, all the dialogue that we've had with Dobbin and his team as we go forward with this project. So this is one of several of these types of events that you all have done over the last couple of years. But we thank you so much for choosing NCC to work on this. Also want to recognize Sasha Nelson's in the room today. Sasha was one of the original people that worked on this project with CNCC, and so a lot of the footwork that was established to get to where we are today has Sasha's blood, sweat, and tears on it. And so really glad you're here today, and thank you for all the work that you put into that. Also want to thank the whole CNCC Craig team for putting this event together. It's amazing. I was thinking about this on the drive over, but Amanda just kind of validated that as we were visiting this morning. If you know anything about this campus, people chip in here. And so anytime that there's a big event like this, like all hands on deck, people from every footprint of the college go into making sure the room's set up and the catering's delivered and all of those kind of things. And so the CNCC staff is remarkable. And my last thank you, I want to thank Amanda and Jesse LaRose, who have really been the points on this project for the last couple of months. Truly rock stars of the academic leadership team. And as Dr. Jones and I run all around the state and do very, very important things, they're here doing all this really hard work. And I appreciate that so much. And so Jesse and Amanda, thank you for everything that you've put into this as well. Thank yous aside, what an important conversation that's going to take place today. And so one of the reasons it's such a no-brainer for CNCC to get involved in this conversation is we are a coal-affected community. We are in the middle of transition for our local economies. And that's something that's got us all a little bit pensive as we try to figure out the what and how does that work and what does that look like. And so as we got to know our friends at the University of Wyoming better and understood what was going on here, it really landed on us what the potential impact of the discussion that we're having here today is for our local economy. David and I were talking before, we got started here this morning, and today's going to be great. What I think is important is contexting what the next step is. What do we do after today? How does that affect our local economies in Northwest Colorado? And so we've committed as an institution to continuing to be a partner with the University of Wyoming through their second and third phase of this. And ultimately what we would like to do, at least here in the space of Northwest Colorado, is make this campus, make this community sort of the nexus for that discussion of what do we do with the potential technologies that come out of this? What do we do with coal mines that are no longer mining coal? How do we turn that into a win for everybody in this room, but certainly for Northwest Colorado? And so we appreciate so much getting to be a partner of this. I think this is exactly the kind of program that the college wants to be involved in, that wants to be pushing in our communities. And so again, a great deal of gratitude from us, Dobbin, for bringing us in as a partner. We make a very public declaration that we'll continue to be a partner in this as long as this is a thing. And so please call on us for whatever you need. But welcome to this conference today. I hope everybody gets a lot out of it. And now Dobbin's going to talk about a whole bunch of science stuff that I don't understand. And so that's my cue to exit out. So Dobbin, thanks so much.
Thank you, Keith and Dr. Jones, CNCC, for hosting us. I feel like when Department of Energy puts these funding calls out, it's always during the holidays. And it's like your first test. Are you really committed to these projects? And as Keith highlighted, days before we all went on Christmas break. I didn't get Christmas break that year, but Keith jumped in and you all at CNCC jumped in to support this project. So we're very thankful for that. I wanted to acknowledge the event sponsor, Alpha Geologic. They donated to this, and we're forwarding that through to our partners at CNCC for putting on this event. I know it's a huge amount of work. So in terms of this project itself, Corsium and the Greater Green River and Wind River Basins. This is the second year of the project. A lot of familiar faces in the room. I presented on this at the AD&C Annual Economic Summits, the JOLT Conference last June that was here in Colorado. I've met with many of you individually, folks at the power stations or the coal mines. A lot of new faces too, so I'm excited to see that. Today, we have most of our project team here, which I'm relieved to see. I don't think I could speak very well on most of these topics. Although I am the project lead, I'm 100% dependent on the team. I just kind of watch them solve these big problems and try to help corral that. So a lot of smart people are on this project, and it's great to have them presenting. We have this morning a few progress updates. So some of the presentations you'll see are really bringing you up to speed of what we've accomplished in the past 2 years. Some of what you'll see this morning are sort of proof of concept, things that the School of Energy Resources have been working on related to coal and alternative coal uses, technologies, stakeholder outreach, which Kyle and Christine will present some of the tools we've developed there, like an app that Kyle will show us some information on. So some of this project update, some of it is things we want to further develop with all of you moving forward. This project will end in February of next year, the phase 1. We anticipate phase 2 funding to be announced sometime early next year, if not sooner. Hopefully not Christmas break again this year. If it is, we'll still go through it, putting that proposal together. Because of that timing, we set aside a large portion of this forum, not for us to stand up and speak to you and just present boring science stuff, but to really have a conversation with this community. I don't think we can move forward in phase 2 proposal without having a lot of very real conversations about the future of coal in these communities in this part of the project. So that's kind of the design of today. Can you pull the first slide up, please? We're gonna go through a brief introduction, reintroduction for those of you who are not familiar with the landscape of Corsium. A review for those of you who have seen this before, and I apologize for those of you who have seen this like half a dozen times now. But this is the Corsium and the Greater Green River Basin and Wind River Basins. We call it transforming and advancing a national coal asset. We really view this part of the world as a coal asset. The nation, there's a lot of diversity here. And I think that's something we'll talk about today, but it's definitely a nice strategy to have that diversity involved. Next slide, please.
Sorry, I'm not
The
most qualified for this job.
That's why we'll use these presentations the warm for this computer here.
There we go. Sorry.
So, although this is a U.S. Department of Energy sponsored project, the standard disclaimer, those views, those things we'll talk about today are not necessarily the view of the U.S. government. So the Corsium initiative, next slide, please, is a U.S. Department of Energy initiative to provide benefit to U.S. coal basins. It is to develop planning for regional economic growth, job creation, technology innovation. And what's important here is this is focused on individual coal basins. The idea here is not to take the coal, the community's economic growth potential of this basin and export it necessarily. It's to develop within this coal basin new potential economic paths around coal. So I won't read all of these, but Corsium itself is focused on coal basins, but critical minerals, rare earth elements, and carbon ore. So this is a big ask in this initiative that the U.S. Department of Energy has put forth. We're looking at declining coal regions and at the same time trying to stand up domestic supply of rare earth elements, critical minerals, and carbon ore. So we're tying these two big problems together into one big project. There are 13 of these projects across the United States. We are area 9 on this map. I will note that 3 of these projects overlap in Colorado. That's pretty unique for CORSIUM. Some of the CORSIUMs overlap multiple states, but Colorado itself has 3 of these projects overlap in this state. So there's a lot of diverse strategy and approaches that will be proposed from these 3 different projects. All of our projects, the team connect in working groups. We have our topical areas. We meet in person at different times of the year, and we meet every month or every other month online on the different categories, the different tasks we cover in this. So this is a national effort. It's like I said, it's a big ask, but I think we can be successful in each one of these 13 in their own unique ways, which we'll talk about today. So a little more about CORSIUM. The DOE approached coal. The next slide's great, thank you. So the DOE approached this project by really looking at coal, or proposing ways to look at coal, by dividing it up. We have the carbon ore portion of this. Many of the carbon ore products are considered critical materials for this country. And then we have, the next slide, please. We have the RE and CM portion. This is really the backbone of the CORSIUM effort and the initiative that DOE has set forth. Rare earth elements and critical minerals. There are a few different measures of what these are, what these should be. So there are numerous different critical materials lists. There are 50 in the current list we use here in the United States. It's pretty much the periodic table. There are a lot of different materials on this list. Some other countries have their own lists, and they're working on similar problems for domestic production, whether it's in the EU or Australia or here in the United States. So tying rare earth elements and critical minerals to coal at first doesn't make a lot of sense. One of the reasons for this, that the DOE has put this forth, this initiative, is the size of the US coal industry, the stability, potential long-term stability, and the ability to steer critical minerals away from standard markets that China and other foreign entities currently control. So that's some of the reason to tie this all together to individual coal basins on these 13 projects. Next slide, please. So this provides us a new way, like I said, to look at coal, how we use it now and in the future. And we've divided this into sort of 2 buckets. The coal molecules themselves, we currently burn coal using the coal molecules. It's also usable for carbon engineering, which Trina will talk about later today. And then, of course, the mineral component, those valuable metals and other potential uses, synthetic materials we can build for waste streams. Next slide, please. And this project includes not just coal, but other resources. So coal waste streams from the power stations, non-spec coals from mining. Basically, this has been expanded to include every geologic material under the sun. And that is really a strength for the greater Green River area because of the diversity of natural resource and extractive industries here. We'll talk about that more today. One back, please. So this project, I won't read the goals and objectives. They are framework specifically for this region, but they are those DOE initiative goals and objectives. What I wanted to highlight here is the project team. First and foremost, we have experts from across the region working on different parts of this project, and the diversity of natural resource and potential availability of CORSIUM of supply chain development. So we have not just coal, but trona, phosphates, oil and gas, hard rock mining, a lot of different materials that are utilized in this region that can potentially be used in a CORSIUM type supply chain development. So regional strengths, we have the large coal mines, large industrial operations. There's a large footprint infrastructure here to deal with these materials. Experienced workforce, the community colleges, CNCC, Western Wyoming Community Colleges, workforce training. This is a region that is not unfamiliar to economic development around natural resources and energy topics. So Not every core CM has the regional strengths that this one does, so we're trying to leverage those and recognize those as best we can. People back one more, please. No worries. Advanced manufacturing is being considered and developed here, Colorado, Utah, within our region. So that's an advantage. A lot of this thought process is already taking place. The AG&C, for example, put out the playbooks for coal for both Colorado and Utah in the past years. So a lot of people in this region are already thinking about that. I touched on workforce development. We recognize the economic downturn of coal in this region. That has provided this region a motivated workforce. People are motivated to see and contribute to whatever the energy transition change turns out to be. I wanted to acknowledge the supporting partners and stakeholders on this project. This is an impressive list. If you compare this to other core CMs, I don't say this is the best, but we've done very well in developing regional support, and that's because of all of you in communication with each other and taking on the willingness to support something like this. And the last slide, I think. So today, the morning will be set up to talk about these individual categories that we're working on, the topic areas under core CM. We have individual tasks. So basinal assessment of core CM resources, that's looking at the coal, that's looking at all the other materials available that could potentially contribute to a core CM initiative here. We're inventorying all of the waste streams, industrial waste streams, how those are used, how those may develop in the future with new technologies. How can we use those to develop new technologies or in new technologies? We're keeping track, building out infrastructure, industries, and businesses. That includes available workforces. Technology Innovation Centers, a big topic. We're going to spend a lot of the afternoon talking about that, so I won't say too much. And stakeholder outreach and education. This project in particular has benefited from great stakeholder outreach and education programs at the community colleges, at the University of Wyoming, and just a willingness for everybody to talk. That's been tremendous over the past 2 years. So each of these areas will turn into a strategic plan. And when this project, phase 1, comes to a close in February, we have to assemble all these pieces, interdisciplinary pieces, into a single strategic plan, strategic summary for the area. And that's really to take catalogs we've built in 2 years and map out potential pathways for next phases of this project. So that's the strategy here. With a few minutes left before we start going through the individual task presentations, I wanted to open the floor to any initial questions about the CM initiative itself, or any specific areas you're working on that may bring up questions.
You mentioned China, their deposits. Have they done anything with coal?
That's a great question. So in China, they are certainly aware of the work being done on the core CM initiatives across this country. And they have done preliminary extraction of rare earths from clays associated with coals and some testing on coals, but there's nothing at industrial scale. And when you compare the potential for those technologies in China to what they already mine and extract, I would assume or presume it's not economically viable for them. They control so much of the world's rare earth supply, critical mineral supply, not just rare earths, that they may not need to focus on that right now. Okay, I'll take silence as I made some sense this morning. So the first 3 topics we'll go through are resource assessment, technology, and business, industry, infrastructure. Some of this, and I apologize in advance, has a little bit of a Wyoming spin on it. Not all of it. We're assessing materials both in Wyoming and Colorado. As the School of Energy Resources at the University of Wyoming, we do have a large focus on Wyoming materials. So we're looking at a lot of that work, some of the results we see in these presentations as lessons learned, and providing us a foundational model to use as we expand efforts in places like Colorado with Colo, Trapper, Boyd Elk Creek, or 20 Mile. So we've learned a lot over the years working on these projects in Wyoming, and we're using this opportunity to expand into these neighborhood regions. So again, I apologize if there is a Wyoming spin on some of this. It is lessons we're applying throughout the project and trying to eliminate that border, trying to look at this as the greater Green River Basin. You'll see in the resource assessment, we've covered a great deal of materials on this side of the border. We've sampled a lot. We've had great support from the miners in this region. And then the technology side, we have Colorado School of Mines and Los Alamos National Lab who have been working on that task. I think you'll be excited to see. I don't want to call it nerdy science branch or Jahan, but I think it's some very cool potential technology pathways we can follow. Later in the morning, Trina will talk about some of the carbon engineering innovations we can look at in this region. Business, industry, and infrastructure. That is one of the the key persons we haven't been able to get to this event. So that's pre-recorded. That's a shorter presentation, and I will be able to field questions after that. We'll take time if there's questions about how we catalog infrastructure and how we look at business as and workforce in this part of the world. So, Bob, if you'd launch us into the first, of course, the M tasks. This is Bob Gregory. He is our resource assessment geologist for the project, and we were lucky to nab him. He was previously state uranium geologist for Wyoming and worked for the Geologic Survey for a long time.
Well, thanks very much, Donovan. I feel lucky to have been nabbed, actually. So, yeah, I want to talk a bit about the resource assessment, task 2. We've covered a lot of ground and we've got more to cover. I will showcase for you the best I can. Basically, we're gathering quite a bit of data. We have some data and we have a lot more coming. So without getting into the specifics of the data itself, we'll talk about where we've got data and where we plan to go. Okay, this picture is at the Colo mine. We're collecting samples off of their ore stockpile there. Many team members, a couple of them are in the picture there. You can see who they are, but as Donovan mentioned, I lead the task 2, which is basin assessment, resource assessment. Donovan is an amazing lead for this project. Very great vision for the whole thing. Our friends at the Colorado Geologic Survey, Mike O'Keefe and Nate Rogers, have been very indispensable. Not to mention Alex Papp, who's here, true coal expert in this region, among other regions actually. Matt Johnson and Lily Jackson have been instrumental in our mine scale modeling, which we'll show a little bit about here in a little while. Okay. So as Donovan mentioned, we are assessing coal sediments and then related associated sediments as well. Coal sediments obviously are the coal deposits themselves and beds within the coal, interburden, overburden, underburden, tonsteins, which is a name for volcanic ash layers within the coal beds. And so the non-coal rocks like coal ash, refuse, acid mine drainage, and other basin materials, this is where it gets a lot of fun because we can look at a bunch of related things within the basin or in the subbasins in the greater Green River Basin. And that can go in a lot of different directions. And the problem with that is it kind of becomes a little daunting because there's so much out there. But the more pieces of the puzzle we can put together for the overall greater Green River Basin, the more potential we have for success with the project. And so geologic model development for coal sediments is a big effort. Matt and Lily are working on that. And The last thing mentioned there is the resource gap analysis. So what we need to do is gather as much data as we can. But we also want to identify where we don't have the data and areas to focus on in the future. So, okay. You saw this picture a little bit earlier with Dobbin's talk. This is at the Colorado mine. It's kind of a fisheye view of a little nice outcrop at their mine. They were gracious enough to allow us to get a few samples here. We didn't get too close to this high wall, but because it's got safety issues. But so the various issues or various areas we're dealing with. Western Wyoming is just outside the Greater Green River Basin boundary proper, but it's at the eastern edge of the Golden Thrust Belt. Kemmer and Haystack mines, Central Green River Basin, that includes the mines around Rock Springs, the Black Butte and Bridger mines. Hannah Coal Field, which is currently not producing, but we did get some samples from the Corridor Research Center from that area. Yampa Coal Field, of course, most of you are familiar with that. It's a tremendous asset to the project. Really interesting and high quality coal there. Atlantic Rim, we're looking at coal bed methane potential samples, I guess, within the Core Research Center samples. We'd like to see what potential lies there. We don't have any of that samples yet, but we're working towards that. And also with the Wind River Basin, and some coal bed methane development there as well. Sample and data sources, obviously the mines. They've been really gracious about letting us sample and providing us with core, and that's always a welcome addition. Outcrops, either within the mine or just where coal crops out in the field. Try to get samples from those as well. I mentioned the Core Research Center. It's a vast resource, tremendous collection of core from not only coal mines, obviously, but oil and gas drilling as well. In the USGS Coal Qual database, it's some of you might be familiar with that. It's a tremendous resource of geochemistry from cores, coal production over several decades. And then we also want to use legacy data from places like Wyoming State Geological Survey, Colorado Geological Survey, anything we can that will augment our sample analysis efforts. Okay. Okay, so here's a picture of a few of the various mines that we've been to. Upper left is the Kemmer mine. That is, I believe that's the lowest bed there at the mine. It's very productive coal seam, and it's got some interesting rare earth element content in it as well, particularly towards the base. And what you see on the right side, that dip slope, that's about a foot or two from the very base of that coal seam. Below that is some outcrops at the Colorado mine. Those little white areas, those are actually sandstone that's kind of been forced up between or into fractures in the mine, kind of a neat feature. But we like to look at things like that because sometimes coal and the non-coal rocks interact in such a way that they can concentrate rare earth elements. I don't think we have any samples from those particular little sandstones, but in the upper right is the Black Butte mine on a cold and blustery day in December last year. That's me trying to stand up in the wind. Below that is an example of the Core Research Center rocks that we sampled as well. And you can see some volcanic ash and coal and carbonaceous shale interaction there. I've been really interested in the interface between coal and non-coal rocks. So we'll talk a little bit more about that. Okay. Same thing on this one. Upper left is some samples that we acquired from the Trapper drilling program. These were after they were, excuse me, after they were sampled at or analyzed at SGS in Denver. Below that is some drilling at Trapper earlier this year, I believe. Kemmer mine outcrop, coal and some sandstone just above that. And there's on a very blustery cold day in December last year, getting some samples from an outcrop there at the mine. So as you can see in the diagram, the western edge of the Green River Basin. That's the Hamsport coal field, Green River coal field, Wind River coal field. And I had the Bighorn Basin because the DOE included that basin as part of the Area 9, Project 9, Orsian projects. The Hannah coal field as well, they included, and we included Granite Mountain because sometimes rocks there erode and work their way into the basin and affect even the coal deposits. Then of course the Yampa coal field, where Colorado, Trapper, and 20 Mile Mines are. The green squares with the check marks are areas where we have samples and data. 20 Mile Mine, we don't have samples yet because they're still coring, and but those are coming. And I was there last week, and I was able to get a few scans with our XRF. Hannah coal field is, as I mentioned, it's closed, but still some outcrops, and we did get some coal samples from the core research center for that basin. Okay, so far we've gotten over 450 samples collected and or analyzed. Some is pending, but we do have more samples coming and more analysis, obviously, from that. So we're hoping to get as many samples as possible, but we're probably going to get at least another 100, maybe up towards 200 when we get some samples from the remaining areas. So what we're doing is we're trying to establish what's going on between, not just in the coal itself, but where the coal interacts with the rocks above it and below it, or within the coal. As I mentioned, the greensteins and shales, we've seen some interesting anomalies in those non-coal nearby rock types. And then we also want to look at minerals that the rare earth elements might be occurring in. Those are pretty elusive. They can be hard to find, but when we find them, we feel pretty lucky because it gives us an insight as to what might be happening as minerals form during diagenesis or subsurface fluid movements, and might help us learn how these rare earth elements are being concentrated and where they're being concentrated and why. So, and then clay minerals are interesting too. We've had a student at UW studying what's going on with clay minerals and how the rare earth elements are entrained in the clay minerals themselves. Are they absorbed on the surface? Are they worked inside the clay minerals themselves? So she's been doing some interesting work on that. Okay. Yeah, before you go, sorry. So on the right side of that diagram is kind of our approach that Montross and Dalvin and others developed. So it shows kind of what I've been talking about, where we want to get samples just above the coal seam, just below it, and within it. And then also the non-coal rocks within those, because that's where we've seen some interesting anomalies of rare earth elements, critical minerals as well. Okay. So this is pictures of examples of what some of our sample sources so far. This is the another core box on the left there. That's actually trona core that was pulled from the CRC. And so what you see mostly is there's a little bit of trona, a little bit of shale, and then also salt, halite. That halite is actually, as you might think, it's pretty soluble. So the core ends up being pretty ugly and partially dissolved. But we sampled that because there's been a little bit of indication that sometimes these big lakes contain some rare earth elements, and as those dry up and evaporates form, where do the rare earth elements go? We don't have very many samples from trona beds yet, but we'd like to get some more. Not to mention there are trona waste streams at mines as well. So of course, mudstone, claystone, sandstones associated with coal beds. I mentioned the volcanic ash and tuffs. That's kind of a subject that's near and dear to my heart because I've studied zeolites and a lot of ash deposits Again, as I mentioned, we've seen some interesting anomalies associated with coal and volcanic ash. I mentioned the trona and halite. And then, of course, data-wise, we want to gather as much data as we can, not only with the current sampling efforts, but also with this existing data. Previous studies, previous publications, and like. So basically, that currently is involving, we've got some interesting work going on with some paleoplacers. Sand deposits, basically, that some parts of sandstones, some parts of certain depositional systems will concentrate heavier minerals. So a lot of those heavier minerals carry with them rare earth elements. And sometimes they carry thorium and other uranium and other radioactive materials as well. But monazite and some of these heavy minerals are very good concentrators of rare earth elements. It's a metamorphic rocks. Pegmatites is a good example. They can be very rich in rare earth elements and exotic minerals. Problem there is that they can be small and isolated. And overall, they're not a great resource in themselves, but they do contribute to putting elements into the basins. So looking at those as well. Okay. And this is a slide showing some of our modeling efforts. In the lower left is the Amphicoal field. David can jump in if he would like to, because I haven't been as involved with the modeling so much as he and Lily and Matt. But basically, ArcGIS based, we take our data and our geochemical data, and it's positioned in the subsurface, I guess, in the cores, and we try to come up with ways to look at that and give us clues as to where we might be able to find more. Are you getting that okay?
And I was just gonna point out the middle image is just very recent work where we've taken samples from the region down here and applied some statistical prediction to the geochemistry we've inserted. And it's very rough at this time. There's actually a little more refined version of this. But if you see the red in the southern part and the blue in the northern part, showing that there are potentially more rare earths occurring in coals for Colo, Trapper, and 20 Mile in those more southernly located coal schemes. That's also where the highlands come up and offer potential enrichment in those coals. So that was a cool initial finding. And you can visit with Brent from Los Alamos. They've been modeling coals in other basins, and I've seen some similar results as well. So
Thanks, Evan. Yeah, I didn't even want to try to interpret that, but the take home point of that middle figure is that it's very preliminary and we need a lot more data. That's where we're going. Next, please. This is some more modeling work that Matt put together based on well logs and where the coals are occurring. And this is the first attempt at this process, and this is on the Kimmermine area. It's near the mine and then outward from there. And the red, I guess, is where the coal occurs. And so I think the idea was to see how easily they could be connected and maybe correlated through the subsurface. Did I get that right?
yeah, so that's exactly right. We tried to approach the Kimmer area differently than this part of the world. With the coal mines and outward connecting all the coal seams in this region, it's much easier to take real coal data and connect those seams in the models for this part of the world. In Kimmer, you have this little dot of a coal mine within a coal field, and there's very little data to extrapolate outside of the current mine area. So this is our attempt to statistically model those coals based on remote sensing data. We can then bring that back to the Kimmer mine, validate that, see how accurate we are. So this is Matt's attempt to do this, and I wish you were here to talk more about the nerdy science part of it, but that's marginally successful, but a lot of good work to be done.
Yeah, thanks, Tom. Yeah, Matt would probably cringe at my description of his work. That's what he gets for not being. Okay, next, please. Okay, so gap analysis, this is a big part of the project as well, because as we mentioned, we need to know what we have and where it is, but we also need to know where we need more data. So as you look at the diagram, everywhere there's not a green spot is pretty much where we need more data. So it's a lot, but some of the data is out there and we just have to get it. Other data is probably tough to come by. And one thing I meant to mention earlier is that when you consider the greater Green River Basin, obviously it's not connected or intricately connected to Wind River Basin or even the Bighorn Basin. But within that basin, that's a boundary of several subbasins. So if you try to connect seams from, say, the Hams Fork coalfield down to the Yampa coalfield, you'll fail miserably because it just can't be done. Partly because they're different ages, but there's so much in between. There's just not connectivity there, even though the basin itself currently covers that area and it looks like it's one big structure. It's basically a blanket over several smaller structures, including the Rock Springs uplift and these subbasins, as I mentioned. So we want to get some, go ahead, Vance, we got some pop-ups there. Yeah, well, COVID methane data, we want to get as much of that as possible. The problem there is that a lot of the wells in that area didn't necessarily core coal. Some did, but some did not. Most did not. So the trick is to go through that data and go through those wells and find the coals that the wells that sample the coal, and so we can go down to the CRC and get that material. Okay. Other basins, well, other coal not within the greater Green River Basin. These involve the Denver Basin. Oh, can you go back?
Sorry. Too many circles.
Yeah. They were supposed to come one at a time.
Yeah, they were. I was just looking like that.
Thanks. Okay, so Denver Basin, Great Divide Basin, Wind River Basin, as we mentioned, and even up into the Black Sands of the Bighorn Basin. That's part of the basin project defined by DOE. So Area 9 basically is Western Wyoming. And so I like to include the Granite Mountains because that does affect what goes on in the basin as those mountains erode and dump material into the basins. Let's see. Yeah, go ahead. So the future plan for additional characterization, as I mentioned, we want to focus on the gaps that we have, but we also want to focus on getting more samples and more data from current mines that we work with now. More outcrop samples where possible, but the problem there is they can be affected by weathering and erosion. So, but they're always good to see what's going on there. But distal to the mines, the areas that we have data, wherever possible, we want to get more data from that. Wireline logs, downhole data is always good, especially when we can find where coal is and we see where to focus our efforts. And that can help us eliminate areas where the coal is too deep that will never be of value, at least in the foreseeable future. And then we need more proximal analysis of individual coal seams to match up with our geochemical data. And then when it comes to the non-coal materials, some examples, this doesn't necessarily include everything that we're interested in, but clay deposits, phosphates, and waste streams from the phosphate operation outside of Rock Springs. Same thing with Trona. We'd like to know a little bit more about what might be available in the Trona bed system itself, but also their waste streams, and we'll hear a little bit more about that later. There's a lot of hard rock mining operations in various places around the project area. We'd like to look at tailings and potential there. And I mentioned the black sands, basically heavy mineral sands that include minerals that have a propensity and a liking for rare earth elements, perhaps some critical minerals as well. Produce water also, and it's kind of a waste stream item, but sometimes that can be very interesting. Modeling needs, as we mentioned, a little bit of, but we need a lot more data, and especially more data from more mines. That really helps us integrate the geochemical data that we have, and it helps us predict where we might find more resources. So I believe that's it. Yeah, so thank you very much. I just like this picture because it shows coal in a very unique situation. Actually, there's a little bit of ash there as well. This is actually from outside the project area, but it's from the Powder River Basin, but it's actually the KT boundary. And so you can see the ash, there's the iridium rich layer there, and coal, as you might expect. So, and of course, there's more information. Contact me anytime, and anybody wants more stakeholder information, contact Christine. So, if you have any questions, I'd be happy to take a stab at it.
We have time for a brief question before that technology team presents, so we can.
How does the Powder River Basin fit into all of this coal analysis?
We have a core CM project specifically devoted to Powder River Basin. And I've actually been working with that project as well. So, I don't know, maybe you have more to.
Yeah.
That, so.
That's right. So School of Energy Resources has two core CM projects. We're actually unique in that we have 2 of the 13 in the country. Our colleague, Dr. Aaron Phillips, leads that effort. The other correlation is a lot of the methods we developed studying coals in the PRB, that was years before core CM initiative began. We're taking those methods and those lessons that are going to apply into these usually the coal we're studying in this part of the world. So there is a correlation with the methodology.
We're taking largely the same approach, but it's got its unique characteristics.
That's wrong. It's just outside.
I think that's in the Uinta project, isn't it?
We struggled with this one, because that coal goes to Utah, it's been nudged into the Uinta, of course, you know. But we've offered to take that on in this project. If the Uinta group is unable to sufficiently study it, so that's something we'll explore in the future.
What is the limit? So, take, you know, Basin.
Down at PL.
One's fine.
That may be the New Mexico, Raton and, you know, I believe that.
Yeah, those are coming down here.
Yeah, it just nudges this northern.
Yeah, it's mostly eastern Utah, but they do.
With them. They're kind of taking care of the Utah coal mines, extending into Colorado, West Elk. It has happened to last project. It's hard to information.
We absolutely love looking at coal in a location we haven't looked before, so if they want us, we'll jump in and grab it out.
Yeah, I'd love to see the stuff. Now I can go that way. Yep.
Will any of your results take a look at the economics of extracted rare earths from coal, or is it all just an availability study?
I think that becomes part of it, but it's not really my forte.
There, strangely enough, DOE did not design an economics task into this first phase. Part of that was to grab as much resource data and inventory that initially as much as possible. That will be a big part of phase 2. It has to be, obviously, we're starting to get a handle on these numbers, not just for rare earth, but carbon ore site and other critical things as well. So, in Technology Innovation Center, with center development strategic plan, which we'll talk about later, there's obviously some economic questions that go into those too.
Yep.
So just in general terms, sedimentary rocks are better for rare earth minerals and critical element concentrations. Igneous and metamorphic have pockets, but they're more isolated. Do I do that right? So, general terms, or is that not?
I would say, yeah, it's a tough question to answer, and it depends on where you are and and what kind of geologic settings you're looking at. But for our purposes, of course, sedimentary is definitely more the person of interest, so to speak here.
And then in areas where uplifts, like the seams where they come together, that's a higher concentration.
That could be, I don't know much about that, but there's a mine where it's intruded, gold deposits are intruded by an igneous body. That's another one I'd love to see, but it's anything we're dealing with GGRP, so.
We'll probably,
Yeah, two questions. How deep do you need to sample when you're drilling for coal outside of the mine area? And any thought in maybe partnering with some construction projects that are moving through this general area to see if they could core for you?
Well, yeah, that's a good point, because the further away from the mine you get, the deeper the coal is going to be, and that's why the mine is there. So, yeah, some of these areas, I know that 20 Mile, for example, they're coring at about 2,000 feet. That's also an underground operation.
We mostly utilize available core, whether it's USGS or they pulled for their own studies or partners with coal mines that are doing their assessment, core drilling ahead of their mining. And I apologize, I'll have to field additional resource questions later in the day. We'll bring Brent and Jehan up to talk to us about the technology piece of this project. So thank you, Bob.
Yeah.
I will say with Colorado School of Mines and Los Alamos National Laboratory, we have, not bragging, probably the two best technology partners on a project like this we could ask for. So thank you, gentlemen.
Where you do the slideshow, so.
we'll see the little diagonal arrows.
Gotcha, that's the one I'm looking for.
All right, good morning. I'm Jehan Lee from Colorado School of Mines. So I'm gonna briefly talk about the sample and analysis and the way to extract using microorganism, and then some application. What can we do with the carbon ore and the coal samples? Next slide.
There we go.
So we receive 3 samples, and then also we got quite a lot of more samples. So we're working on a sample prep right now. So mudstone sample and pyrite sample and a coal sample, and we ran the ICP analysis for elemental metal analysis and XRD and automated mineralogy to characterize the sample. So this is just a few elements that we are interested in the sample. So mudstone, pyrite, and the coal samples. As you can see, there's cerium, cobalt, lanthanum, neodymium, and zirconium. So mudstone contains quite a lot of zirconium, but a pyrite sample, interestingly enough, has a high concentration of cerium and lanthanum. And a coal sample, coal is like a clay sample. Clay sample is relatively lower concentration of the metal elements. The distribution is similar to mudstone. So those are the quick ICP analysis result. Next slide. And these are the mineralogy studies. So, I mean, majority of the gangue material from mudstone was quartz, and pyrite is, I mean, obviously pyrite, and a coal and a clay material is a lot of different clays, and it has a small concentration of pyrite, potassium feldspar, and other elements. Next one. So using I mean, rare earth extraction, critical materials. I mean, majority of elements we can extract using just sulfuric acid, and we can use hydrochloric or nitric or other element, acid, but sulfuric acid is commonly used because it's less corrosive and then easy to treat in a downstream process. But the concentration of elements, as I show you in the plot, is in a relatively lower concentration. I mean, I'm from gold. I used to work for gold mining company, and so we deal with 1 to 2 ppm. And how about like several hundred ppm? Is it really low? Yeah, compared to the precious metal, it's relatively low. So we can use acid, I mean, the inorganic acid or organic acid. We can keep supplying the acid in an extraction system, but the operating costs can be higher. So we use we call it bio-leaching using microorganisms. So bacterial leaching, just one slide. If we have a metal sulfide, I mean, MS means metal sulfide. So pyrite and most of the coal sample, we have enough sulfide. We don't need a lot, and 0.5% and 1% sulfide is more than enough to produce sulfuric acid to extract the metal. So metal sulfide will be leached by the ferric ion. So how about acid? Yeah, acid provides a matrix, but actual oxidant to leach metal is a ferric ion. So we have a high concentration, I mean, a little bit of concentration of ferric in the solution. So the microbial activity keep providing ferric ion and also sulfuric acid. So as you see on the top, the metal sulfide will be leached by the ferric ion Fe3+ under acidic condition with a proton, and it's going to form metal cation and polysulfide and Fe2+. So ferric reduced to ferrous, right? And then metal will be in the solution as a sulfate. And then we need to, I mean, as I said, we have a ferric in the solution. So microbial activity oxidize the ferrous ion back to ferric ion. And then from the pyrite and the sulfide oxidation, we can have sulfuric acid, and then also some microorganism deoxidize those ferrous ions back to ferric ion. So we have a continuous supply of ferric ion in the system, and from the sulfide oxidized to sulfate, all the way to sulfate, and then it's going to form sulfuric acid. So we can have a continuous acid and ferric ion in the solution. So that's just one slide about the microorganism. And what do we need? I mean, Bob showed the acid mine drainage. So 3 recipes of acid mine drainage: sulfide, air, water, and the microorganism. So those microorganisms are naturally occurred, is abundant. So that's why we had an acid mine drainage happen. So using naturally occurring microorganism and provide a little bit of water, a little bit of nutrients, it's going to happen. So that's a bio-leaching of sulfide. So we are working on those samples and in a lab scale, try to extract the metal. So most acid soluble elements can be dissolved in the solution. Next. And so some of the advantage, as I said, the leach agent in the process is regenerated, ferric ion and acid, so leading to less chemical addition. So we had an environmental advantage, and it provides a route to handle low-grade materials. So if the grade is high, we can use expensive, some sort of a snake oil, but the grade is low, so we can use the microorganism to extract the metal. And other lixiviant can be generated microbially. I mean, not just a sulfuric acid and a ferric. So some microorganism can generate, I mean, even alkaline solution and some organic acid that extract the rare earth and the critical materials. So. And I show a few examples that what else we can do from coal. So one is, yeah, that's fine. So high temperature process, so graphite conversion. So graphite is, we use a lot of, I mean, carbon and graphite in the battery electrode. So simple graphitization of coal, it happened in a very high temperature. So we add a little bit of B2O3 addition, so increase the process. So it can produce graphite with very high, physical property that we can use in a lithium-ion battery, the anode. So these days, lithium battery recycling is really big thing. But how about the carbon material? So we call the black mass. So those we can produce the high quality graphite from coal sand. And then the other one is using coal tar pitch mixed with the cobalt carbonate and tetrahydrofuran is one of the chemical. So we can make the very fine high quality graphite, carbon graphite. This is a transmission electron microscope. It's a very small particle. As you can see, this scale wise is 10 nanometer. So those are in a nanometer scale graphite powder that we can use in a different application. And activated carbon. So we use activated carbon simply just filtering water and some other industry as an adsorbent. So high absorption for the characteristics of activated carbon is widely used in an industry. So why don't we? Since we talk about the carbon ore, and why don't we make the high quality the activated carbon? So it's also the chemically and also thermally synthesized in a high temperature with a little bit of the potassium hydroxide. So we can make this hydroactivated carbon, but it's activated carbon. So we can use in a battery material also, and then with the absorbent. A lot of filtering and the clarification, clarifying water and processed water and even drinking water. In the Brita filter, you have all those activated carbon in there. So we can make the high quality, value added product out of this coal material. And the other one is using because the previous example is we use a high temperature, and instead of the thermal energy, so we can also use the microwave. So microwave assisted conversion is very low energy and low temperature method to process. So multi-layer graphene can be grown. So microwave can, we use microwave to cook, right? But microwave can be used in and provide the energy into the coal, and then also people try to decrease the comminution energy using microwave. So it's one other method we can use. And solvent extraction is also widely used technology to increase the grade of the material. So the coal has some proportion of naturally occurring crystalline carbon. So this is a relatively new area to me. So because solvent extraction to me is like increasing the copper concentration in the solution, but not like a carbon. But we found out that we can use this solvent extraction technology to extract the graphite in a needle coat as a replacement of the amorphous carbon. So it's a needle-shaped carbon can be extracted chemically, not the physically, because solvent extraction is a chemical method. So that's one other example that we can do. And also structural material. I think Bob's slide shows briefly about the structural material. So last, 5-10 years, a lot of people use what we call the geopolymerization using fly ash. So fly ash, bottom ash, even we wanted to extract the material out of it, but also fly ash is very fine spherical particles. So those added in the matrix, it make the concrete-like structures more, a lot higher, having a lot higher strength. So we also try to make those the byproduct is structural material or construction material. But if you use just as is, we get the bottom ash or fly ash and use that material to make the brick. And what happened? Because in the geopolymerization, we add a lot of caustic, and then caustic behave like a leaching agent. So that what that means is when it's rain or it's exposed to moisture, that heavy elements in the fly ash or bottom ash will release. So we literally, I mean, I don't want to say, we literally make a toxic brick. So using the chemical extraction or bio leaching, we can extract all those metal from the coal or coal byproduct or fly ash. And then the remaining material is much cleaner. So we can make this structural material without worrying about the releasing those heavy metals. So that's a big benefit. And a carbon composite, so it's also another high temperature process. So we can extrude the fiber from the coal or coal material. And then as you see the carbon, I mean, you've seen those, the, what do you call that? The carbon material that we can use in a car, like in a dashboard and many other applications, and even a high-speed tool. So that's another application we can manufacture from the coal. Okay, next one. And molecular sieve. So using molecular sieve in the oxygen plant, we try to get all those oxygen from atmosphere using molecular sieve, and some chemistry also use this technology. So that's the one of the is that the last one, I guess? Oh yeah. Yeah, and then nano material, so carbon nanotube, carbon fiber, as I show you in the TEM image, it's just like a 1 or 2 nanometer size, a particle, or we can make a rod or different shape. So that's one other chemical process that we can utilize this carbon material. So 10 minutes. Okay, that's your turn.
We'll do joint questions pending Gotham's control of the schedule.
Is this your slide?
Yeah. So inspired by Jay Han, I decided to make a similar slide. So we've been working on some similar materials, but as you know, Bob and Dobbin have highlighted, it's a diverse basin in terms of materials. So we've been waiting on some samples, so hopefully we'll continue those discussions here. But we've also been working and thinking about black sands, as Bob mentioned. I was handed a bag of Trona last time I was at the University of Wyoming. So once our instrumentation is back up and running, we'll be working on that. And then recently, we've been thinking a lot about phosphate waste. And part of that is thinking about it from a geologic resource assessment. But we also have believe it or not, Los Alamos National Lab has a biosciences division. And so they've been starting to think about bioleaching of phosphates for rare earth extraction. And so we've been doing some interesting work on some of their synthetic phosphates and how that might be applicable to natural phosphates. So a similar suite of analyses. The main difference being is there's a huge interest because of our longstanding background in analytical chemistry in applying XRF technologies, both portable ones that can be field transported, and I think that's going to be really critical as we develop these methods and these practices into the future. And so I have a couple-year interest in developing this technology along with strengths in machine learning and artificial intelligence that our laboratory has. And so that's part of this core CM, but also the Powder River core CM that I'm part of. And then what I really want to take a few minutes on, I think it's my next couple of slides, is show you some really interesting images from micro XRF. So this is a not particularly useful plot, but it is effectively a graphical representation of some images I'm going to be showing on my next 2 slides. And what these are different elements and where they appear in terms of an energy spectra when they're excited by X-rays. And so the net take home is that the higher the peak, the more of that given element. there is. Okay, and not all elements are readily detectable, and that's where a lot of the machine learning and AI techniques are going to come in, is can we find pathfinder or companion elements and use a machine learning AI model to readily make those more detectable. So if we go to the next slide, what we're going to see here, this is a small coal sample shown in the bottom left, and I do apologize, it's so washed out, mounted in some epoxy resin. And what we have done here is we've rastered a micro X-ray beam across this entire sample, okay? And so you can see the scale, about 10 millimeters. And so the beam size, I think it's on the order of 40 microns, but it just shoots every little spot on that coal sample. And what we can then do is make elemental maps. And in this case, the ones I really want to highlight here are calcium, so top middle, and then cerium top right. So cerium being a rare earth element of interest. And what we see is that the cerium anomalies, and in this case, the anomalies being the elevated concentrations, tend to be co-hosted with the calcium, and they tend to be co-hosted along fracture boundaries within the coal themselves. And so this gives us some hints and some insights as to how the rare earth element deposits within the coals came to be. They're probably related to water. But it also gives us some clues and some future insight into how we might be able to extract these, either co-hosted with a coal extraction operation, or in, say, Bob mentioned, I think it was the Hannah mine, if I got that name correct, a shutdown mine. Can we reoccupy such a mine and think about a technology like in situ extraction, taking advantage of the fact that the elements of interest are within fractures, and we can then get water or other lixiviants through those fractures, okay? So these are kind of pie in the sky ideas, but they're really important aspects of this phase one. So if we go to the next one, and we can just kind of see, also, I apologize, strontium is so blown out. We have a lot of background noise, but we do have strontium. We do have sulfur, surprisingly in this case, but we also do even have some anomalies of manganese, which has a developing interest as a critical. Okay, if we move on to the next slide. The other thing, I think we're actually going to skip this slide given time. The other thing that I can't take much credit for at all, this predates my time at Los Alamos, is a nature-based solution to rare earth extraction from, in this case, mostly acidic waste products. And so this could be down the chain from the bioleaching that Jehan was talking about, but really taking advantage of the fact of where do we find rare earth elements in nature? And in this case, thinking about pegmatite deposits. And they're almost always co-hosted with fluorides, right? So what our team of geochemists did is they thought about this thermodynamically, and then they built a benchtop experiment, if we go to the next slide, that essentially took an acidic solution pregnant with rare earth elements. In this case, I think it was lanthanum, neodymium, and erbium, if I remember correctly, at about 500 parts per million in that solution. And they flowed 2 liters of that solution across chipped fluorite. So in this case, taking advantage of a very low cost ion exchange resin effectively, right? And what they were trying to do was induce the conversion of fluorite to fluorocerite. And they did this at elevated temperatures and elevated pressures. And what they found is that they could extract from this solution nearly 100% of the rare earth elements, right? So now, again, this is a 1/4 inch diameter tube that's a foot long. Very much pilot scale, bench scale. But what we're really starting to think about now is how do we scale this up in an economically viable way, right? And it's actually the subject of something that we're thinking about with the University of Wyoming at this very moment. So if we go to the next slide, what we see also is that along the length of the column, so from left to right, we see that the extraction of the rare earths is not uniform across that length of the column. So we may have some ability to separate the specific rare earths instead of just having a pure mixed rare earth fluoride. So there's lots of real potential here. Go to the next slide, please. We've been doing some recent experiments. I actually got an email about it last night, where we recreated this mixed rare earth fluoride at an even higher concentration. And after 1.5 liters of solution, we still haven't had any rare earths come through that column. So there appears to be an incredibly high capacity to separate these rare earths into a mixed rare earth fluoride. Now, you say, if we go to the next slide, what good is a mixed rare earth fluoride? Well, it's not as good as a separated rare earth fluoride, but one of the things of rare earth fluorides is there are ready-made industrial applications of those fluorides, and they're also a precursor to rare earth oxides, which is the main industrial component. So there's a lot of thinking to do here. I'm a geologist by training, I'm not a material scientist. So it'd be great to continue to talk with material scientists about potential rare earth fluoride uses. Go to the next slide. The other thing we're really thinking about within the Greater Green River Basin is what are the value-added products, potential exploration. And me being from Los Alamos, I have a decided interest along with 13,000 of my other colleagues in many of the other elements that are low down on the periodic table, right? And there's an abundance of those within the Greater Green River Basin. And with the burgeoning reemergence of the new nuclear industry, there's a very strong and keen interest in this basin and this project to explore the potential for that as long west side of value-added products of rare earth and other critical minerals. So I'm not going to go through this entire list, but it's a really exciting time. I'm really excited to be part of this project and to see where this goes and continue to work with partners like you guys. Now I think we might have time for questions.
We designed a little extra time in the morning in case we ran over. So thank you, gentlemen. Could you maybe one quick question and then save the rest for our networking break that's coming up soon. The next presentation is only about 10 minutes, so.
I got one question. What about your alkaline fusion on separate the rare earths and taking that, bleaching with water, remove the phosphorus, and then come back with chloride mixed with rare earths and then precipitate the phosphoric acid? What's the potential of that?
Yeah, do you want to take that, Jay? On more of an
Yeah, we in alkaline fusion, and also we call sometimes acid baking or calcination. So it is possible, but as I said, it's all economic. But at this moment, I don't think we need to worry about economics, as David mentioned that. So yeah, we definitely can try, but we wanted to utilize some non-conventional method to extract the metal. So that's absolutely.
Now I got one more question that's a little bit off. Recently, they've got some information out on the assay for arsenic and selenium. It's compounded with rare earths, and ICP will actually give you false negative report because of the rare earths, especially metal, that's positive charge. And I've never been able to find any more information on how they get around to be able to make sure the right analysis.
Interesting. I hadn't heard that. I think something that'll be important to verify that will be to use complementary ICP methods like optical emission spectroscopy that are not charge state dependent for actual detection. And so you do have some limitations in terms of the detection limits with that method, but it at least gives you an ability to cross-validate, maybe not every single sample, but, a random selection of them.
May be able to test that with solutions.
Yeah.
I think we'll hold further questions for the technology folks until after the next presentation. So thank you both.
So that last one was. I can't. So.
So the next presentation, is from Angela Tour. She's a PhD candidate at the University of Wyoming in the Center for Business Economic Analysis. They've helped us greatly through inventorying infrastructure, businesses, trying to understand current industry in this part of the world. Christelle Kalop, Dr. Kalop has led this task, is unable to be with us today. So this shows some of the preliminary work that Dr. Kalop has done. Our PhD candidate is working on. It's an interactive tool they've developed.
Hello, everyone. My name.
Sorry. You'll notice an immediate gap in some of this presentation. And one purpose of this forum is to seek out information from the miners from the industries in this region to fill that gap. As University of Wyoming, we have a strong understanding of those businesses and industries in Wyoming. And as we reach out into Colorado with the Consortium and Kirby, we're doing this in Montana. These are kind of the last steps we're struggling with to include as much information from Colorado and Montana into these projects as we can. So you will notice that in the presentation, and hopefully that opens the door to interviews with many of the industry folks in this part of the world to gain that information.
This is, yeah, that's the key. That's what I did.
Okay. We're making sure our online participants can view this. Thank you.
Hello, everyone. My name is Angela Tour. I'm a PhD student at the University of Wyoming Economics Department, and I'm also a part of the Consortium project here. Unfortunately, I couldn't attend the forum today, but I am hoping that this presentation will provide a comprehensive overview of our work on this project. This presentation is loosely divided into 3 parts. First, I will briefly recap the CM supply chain structure. Then, I will talk about what we are currently focusing on in terms of CM research and what has been done so far. And finally, I will conclude the presentation by talking about our next steps. The CM supply chain incorporates 7 sectors, as identified here in the top row. The state of Wyoming has businesses operating in each of those sectors, except for Elwing. I will not be talking about these elements today, because they were covered during the presentation last year, and they're not today's focus. In terms of distribution, in Wyoming, 3 industries, exploration, mining, and processing, account for 80% of businesses that are in the CM supply chain. Also, those 3 industries employ 95% of the total number of people that are involved in CM. On the slide, the outer pie represents the share of employees, and the inner pie represents the share of businesses. So the numbers in brackets are the actual numbers of businesses or employees that are involved in each of the sectors. Our current efforts is focused on determining how existing businesses and workflows can be successfully integrated into the CM supply chain. To that goal, earlier the project team carried out several business surveys. Unfortunately, this approach was not very successful due to low response rate. So this time, we're changing things a little bit, and we're going to schedule Zoom or in-person interviews with businesses to discuss their perspective on CM supply chain participation. We're planning to interview at least 4 or 5 businesses per supply chain sector. The interview focus is in the following areas. Foreseeing supply chain participation benefits and costs as perceived by businesses, and this includes barriers to entry in the short term, medium term, or long term, competitive pressure, and so on. Government regulations and assistance in terms of just entering the consumer supply chain or for businesses that are already in the industry. Workforce development, which includes education, training, and attraction of new talent to the state. Technology and equipment requirements. Finally, transportation and infrastructure to support the consumer supply chain. Additionally, in the longer term, we will be conducting economic impact analysis to assess the overall contribution of the consumer supply chain to the Wyoming economy. We also think it is important to identify the impact of consumer industry on its major stakeholders, such as the state, business, and workforce. Now, I would like to talk about another major part of the team's effort, which is a story map that Crystal Halab, current project lead, and her team have been working on. The story map is an interactive map of the post-game infrastructure in Wyoming and adjacent states. The map provides its users with information on each of these areas identified at the top that are critical for the post-game supply chain development in the state. For example, in coal sources and byproduct section, it displays coal-fired power plants and different types of mines. Each mine, shown as a triangle, can be clicked on to learn more. In addition to that, users have access to some basic information about each county, such as population, area, and so on. Another interactive map focuses on the upstream supply chain, which includes mining of resources and physical separation. The interactive map shows all of the relevant businesses and again provides some general information about them. The website then proceeds to show the transportation network by type, including rail, road and air, and pipelines. We are developing a map for energy and water sources. For example, the energy map now only shows electric power transmission lines, but the goal is to expand it so it shows wind farms, solar panels, and all of these other objects that can be of interest. We're also planning to add information about environmental liability and workforce development in the future. So the overall goal for the story map and for each interactive map is to show Corsium infrastructure in Wyoming, its impact on the state, and the contribution to the state's development. This is the end of my presentation, and I would like to thank you for your time and attention. If you have any feedback or suggestions, or you would like to share your business perspective about Corsium supply chain, please do not hesitate to contact me using the email provided. Once again, thank you. Have a great rest of the day.
All right, so we've done a tremendous amount of work in that area. Anywhere you saw Wyoming, please insert the region. As you can see, we have large gaps. So we're growing our understanding of those catalogs out, what we already know. What she did not touch on is those will include the Uinta area, will include the Front Range of Colorado, anywhere advanced manufacturing downstream supply chain components will also be present. So this tool will gain a lot of mass in the last 6 months of this project. But I wanted to emphasize those interviews are critical to fulfilling that. And that's where we really struggle to get data. So stay tuned for those requests. We have a networking break. It was 15 minutes. We'll give you 10. We'll come back here at 10:15 and see the next segment of the project update. Thank you. Thank you for losing 5 minutes to the break. We have good presentations in the second half of the morning here. For those of you who are on the non-technical nerdy science side, you'll find these. Well, they'll have some nerdy science here too. We'll mix it up, but this is really focused on communities, education, information sharing. We have a presentation on communities and social environmental justice. In the next phases of this work, this will turn into community benefits planning. This is a huge part of these projects. Technology innovation centers. Trina will present on that. I will introduce that topic. That strategic plan I talked about, bringing all of this interdisciplinary work together, results in us proposing strategic pathways for technology innovation centers. That's the placement of the science in these industries, these coal-based areas. How do we do that? What do we propose there? That's that one gives me heartburn, how we assemble all of that and make those propositions for an entire region. So I'm very interested in talking to you all about that. We have an afternoon session to discuss more of that with all of you. And then outreach and education. Some of the tools we've developed there, some of what we've accomplished to date. And then Amy Murphy from Western Community College as our guest speaker this morning. We'll talk about workforce development. So this is a recorded conversation. If you have questions, we'll field these later in the day. Selena will be here in the afternoon as one of the chairs of our dialogue sessions.
Right. Good morning. I'm gonna share my screen here. My name is Selena Trace. I am a research scientist at Blue Energy Resources. I wish I could be there with you this morning. I will be there this afternoon though. So I look forward to seeing you all then and speaking to you all then on the panel that I'll be a part of. But right now I'm going to talk a little bit about the work I've been doing on these projects related to our environmental justice subtask. And understanding the social and environmental justice concerns related to developing critical mineral industries and related to these projects and the community consideration. How are the communities being impacted or could be impacted by these developing industries? So the Corsium projects, these DOE funded projects, really at their very heart are supposed to be centered on benefiting communities. So they
They are focused on catalyzing basin-wide economic growth and job creation. So as part of their fundamental purpose, the benefits they provide to communities are foundational. So really understanding the unique needs of these communities where these projects are happening is fundamental for these projects. And of course, communities, coal communities in these areas, in the Great Creek River Basin, the Wind River Basin, and our other Porcine project up in the Powder River Basin. So in Wyoming, here in northern Colorado, as well as in Montana. We're seeing, of course, huge transitions to coal communities. Industries are changing, demand for coal is changing. We see power plants and mines closing, and it's creating big changes for communities and how communities operate. This, of course, includes revenue loss, both state and local revenue. There's been job loss. There's also huge population loss. So as we're moving forward with these projects, we're keeping all of this in mind. This is the context in which we're developing industries. And of course, with developing industries, it brings with it new opportunities, but also new challenges. So developing these critical mineral industries have this great opportunity to provide economic development, to create jobs, and to support these coal communities. But there are also new challenges. These won't be the same industries and they won't have exactly the same dynamics. There will be many unknown social and environmental impacts that need to be taken into account as we develop them. So the challenge is really to address the needs of the communities and create jobs and revenue and with these potential new industries. So that means that there could be potential social and environmental justice concerns related to developing these new industries. So to talk a little bit about what we mean by social justice and by environmental justice, so we have language to be understanding. This definition of social justice is that it really has to do with the distribution of advantages and disadvantages across all different members of society. So regardless of race, background, socioeconomic status, etc., who is getting the benefits? Well, who is bearing the burdens? Understanding this and how might it be unequal? Environmental justice is a subset of social justice that really focuses, again, on that distribution of advantages and disadvantages, but focused on those environmental factors, which is why it's really important for energy projects, because anytime that we're developing energy projects, there is an environmental impact. This is the definition of environmental justice that largely the federal government uses. It's from the United States Environmental Protection Agency, and it focuses on the fair treatment and meaningful involvement of all people, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws and regulations and policies. So there's a couple of really important key phrases in there of what this is getting at, including fair treatment. So that means the same degree of protection for all people. And meaningful involvement means access to the decision-making process. Who has access to be involved in that decision-making process? Within environmental justice, I think it's also useful to recognize that there are different subsets of environmental justice, different frameworks through which we understand what environmental justice is. So the one that we think about a lot is this distribution on the bottom here, which again has to do with kind of that distribution of benefits and drawbacks. Who's getting the benefits while who's bearing the burden? There's other ways to think about environmental justice as well, including representation. So who is represented in the decision-making process? Whose point of view is represented? Process is another framework through which we can think about environmental justice, which really has to do with how is the process set up to take into account different points of view in decision-making. Is it fair and transparent? There's another subsection of environmental justice that is often referred to as energy justice, which focuses specifically on the impacts of energy development and energy projects. And that one incorporates all of these different frameworks for environmental justice. And so it's really something that we can look at through all of these different lenses and should look at through all of these different lenses. Environmental justice grew out of a social movement. It was really a grassroots movement to account for environmental impacts to different communities that maybe didn't have a voice in decision making. And since then, it's very much grown and been adopted by governments and organizations. So it's been institutionalized in different ways, including at the federal level. Most recently, in 2021, the Biden administration established the Justice 40 initiative to start to take account of environmental justice concerns. And what that Justice 40 initiative says is that 40% of overall benefits of certain federal investments should flow to disadvantaged communities. So that hinges a lot on this definition of what is a disadvantaged community. And there are different ways of defining it and different terms that are often used. So underrepresented communities is sometimes used as well, or historically marginalized communities, but it really has to do with identifying those communities that maybe are at risk for different reasons, or have been historically underrepresented. And so these can be both geographic area, people living in geographic proximity, as well as more geographically dispersed communities, such as migrant workers or Native Americans. And there are many different screening tools through which we can identify disadvantaged communities. The federal government has several, including this one you see right here, which is the EPA EJ screen tool. DOE also has one, and they focus on geographic data about different communities that falls into different categories. So there's socioeconomic data, including race and income. There's environmental exposures and burdens, as well as fossil energy dependence. How many jobs, how much income is dependent on fossil energy jobs and industries. Several states have also developed their own screening tools, including both Colorado and Wyoming. Colorado's is this Enviro Screen tool developed by the Colorado Department of Public Health and Environment. It's not one that I have looked into very much, but Wyoming has also very recently just developed their own as well. By the Wyoming Department of Environmental Quality, called a Special Focus Map. And this is really opportunities for states to compile information that is specifically relevant to their state. So in Colorado and Wyoming, that might be taking into account sort of the smaller communities, more rural communities, and what are the needs and concerns of those smaller, more rural communities. So the environmental justice at the federal level is really being incorporated into the Department of Energy grants and funding through what they're calling community benefits plans. And community benefits plans are required for every application for federal funding at this point. For about the last little over a year, they've been required. And the purpose of those is to ensure that these federal funded projects are supporting the goal of building a clean and equitable energy economy. So ensuring that communities are actually benefiting from these projects. They typically consist of 4 different parts. So there is a community labor and stakeholder engagement plan. How are communities being engaged and communicated with throughout the project? A quality jobs plan. How is this contributing to workforce development and creating jobs? Diversity, equity, inclusion, and accessibility plan, which focuses on how are we making sure that this is an inclusive project and that it's equitable, that it's taking into account diverse stakeholders and audiences that will be impacted by these projects. As well as, again, that Justice 40 Initiative plan. So making sure that it's in alignment with the Justice 40 Initiative and that benefits are flowing towards these disadvantaged communities. So each community benefit plan is specific to the project. So for each grant, you develop its own, and it's specific to the community that it will be impacting. So with the current phase of the CORSIAN projects, they didn't require a full community benefits plan. We applied for them right before that started to be required, but they did account for a lot of these same concerns through different subtasks. So there are, of course, outreach and engagement subtasks that's taking into account a lot of these concerns, as well as the subtask related to environmental justice that is responsible for considering not only the potential environmental implications of these projects, but also how does the project plan to partner with communities and engage with communities to ensure environmental justice throughout the project. So as we look to future phases of CORSIAN, we do anticipate that we'll be developing full community benefits plans for those future projects. So currently what we've been working on for this phase of the project related to environmental justice is really understanding what would an environmentally just critical mineral industry look like. And we've broken it down into different subcategories: social, economic, and environment. So understanding the social implications of developing a new industry. What are the labor practices? Are there fair wages? Are there fair health and safety practices? Are we partnering strongly with communities? Is industry partnering strongly with communities to jointly build up these industries in a way that truly supports the community? Including strong community involvement in decision making. Including community engagement with tribal nations and ensuring that these projects and these industries support tribal energy sovereignty. We're also looking at economic factors. How will these industries create jobs? And will they be local jobs? Will there be opportunities for local workforce development for people who currently live in these communities to get education and training to participate in these new industries? Will they generate state and local tax revenue? And then there are environmental considerations. What will these projects do to mitigate or minimize exposures, pollutants, wildlife impacts, land use impacts, minimize land use change and fresh water use, and to utilize waste streams? There's a real opportunity here to develop circular economies. So we've been incorporating environmental justice into many different phases and parts of this project that as we've been working on it, including building strong community partnerships. So that includes partnering with Western Wyoming Community College in Wyoming, partnering with Colorado Northwestern Community College. It also is looking at what are the community values within each of these communities, and will these industries be in alignment with those community values? At University of Wyoming, we've done quite a bit of work to understand what Wyoming residents value. We've done a series of reports on social license to operate for different types of energy industries, and then understanding public perceptions of all different types of energy industries, including critical mineral industries. We have done a series of different webinars and meetings to engage with stakeholders, to provide information. And to make sure that these projects are being developed in a way that is place-based and takes account of the unique needs and concerns of specific communities, that no industries can be built one size fits all, that it needs to fit within the needs and concerns of the communities themselves. Thank you. That's all I have for now. Like I said, I will be there this afternoon. I look forward to meeting all of you and talking with all of you soon. Thank you.
We'll field questions with Selena when she's here this afternoon. We have our second dialogue session of the afternoon with Selena as the chair of that session. We'll tackle some of the details she talked about. I will say we are lucky to have Selena. She, I think, does community benefits planning for every single project we do. So we're actually lucky to get here today to even chair this session. We talked about strategic planning and all these tasks we've been doing, the interdisciplinary tasks coming together into this final strategic plan, which results in technology innovation center strategies. So I am not as familiar with the frameworking of this as the previous task lead, Richard Horner and Boston Strategies International. They are an energy supply chain investment firm that we hired temporarily to help us build an understanding of how we design technology innovation centers. I'm the interim lead for this until we have an energy economist in the building, which we'll have soon, who could help finish this task off. But I can introduce some of what we decided on. Other than look at the supply chain, let's say we put a coal mine and an end user upstream to downstream, and just say that feels right. We need to set up a whole series of measures, criteria, matrix to make definitive decisions on which technology pathways we want to take and how we get there. So I'll briefly touch on the criteria and some of those decisions. There's a lot of information I won't touch on. We will have a final report describing those decisions. I'll be working in the communities, the different entities, both in Wyoming and Colorado, to help us in those decisions, those things that we'll be proposing in the next phase of this project. So if we could go to the first slide, please. So the first thing we did is set up guiding principles. I won't read these verbatim, but we wanted to have something we could rely on and make an argument on why we've chosen to go down this pathway, whether it's critical minerals extraction, a particular element, a particular carbon material, maybe it's a non-coal material we want to stand up in the industry, which technologies we've selected. So sustainable advances in technology. Our speakers this morning talked about more environmentally benign, environmentally friendly methods, using existing waste streams, leveraging geographic, local, regional resources. That's obviously the design of CORSIA. We want to realize the potential of these resources as best we can regionally. We're not looking to outsource these to faraway places, right? We want to utilize the infrastructure and the resource here, designing these innovation centers. Environmental considerations like water availability obviously has to be a big part of it. Competitive advantage goes without saying. These need to be durable industries. The economics have to make sense. This second to the bottom, associated with the degree of novelty and newness. We're looking at these materials in new ways, especially the coal-based materials. We have to look at these with novel and new technologies. We have to figure out how to best handle these materials to get out the valuable, critical materials. If we were doing this already, it wouldn't be novel. So these are the hurdles we have to clear. And then I talked on economically sound and deliberate market impact. The market impact side of this, I think, could be variable. We know we have to get out from under the weight of Chinese rare earth dominance and other critical mineral dominance. Some of these may not have, some of these potential technology pathways may not have an initial market impact as significantly as we'd hope, but they are those initial steps to get out from foreign dominance of critical minerals and start to build domestic supply chain. So that's kind of a moving target. Next slide. So selection criteria. This further refines those guidelines we just went through. So anticipated shortages and reduced foreign dependency, that is the backbone of CORSIUM. It can be very hard to anticipate those shortages. No one thought the war in Ukraine would kick off. No one thought the Middle East overnight would start to broil. We see critical minerals, the 50 on that list, overnight shoot to the top. So vanadium is an example. It's everywhere in this region, especially. It comes out of uranium mining operations. 5 years ago, nobody cared about vanadium. Suddenly, with Russia being one of the large importers to the United States for vanadium, we've moved vanadium very high on the critical minerals list recently. So scarcity challenges as part of anticipated shortages, those things that cannot be fulfilled from other sources. So what's unique in the Green River Basin, Wind River Basins, that might set these resources as a paramount source? What's unique that we can find here? Feedstock availability and sufficient quantity. That's exactly why CORSIUM critical minerals are tied to coal basins for the CORSIUM initiative. We know we have a lot of coal. In this part of the world, we have a lot of other materials, trona and phosphates we've touched on. We would love to learn more about those and figure out how we can integrate those into technology innovation center planning. So those things that we have in most abundance, that's on the, obviously on the front end of supply chain. I think we lost the screen there. Sorry. So this third from the bottom, potential to co-process different source feedstocks. We highlighted a lot of different potential technologies. This is critical for this part of the world. You can look at other coal basins and really focus just a handful of technologies on one large volume product. Here we have different coal mines, different coal seams, everything is different from location to location. So identifying the nuances and the strengths of those individual coal seams with individual mines, individual materials, not all trona is the same. The phosphate source is different. The industrial waste streams we look to incorporate in these processes are different. So that's a big hurdle, but that's part of the design in the select criteria. Job creation is obviously important. As Selena talked about in social and environmental justice, we're looking to assist in standing up the declining coal communities. So if we predict or suggest a particular technology pathway, does it fulfill the goal of renewing those jobs? Does it take a workforce that exists now and utilize it well? Part of the criteria. And I think the others we can skip. We've gone over those existing resources and things like that. So in the first year of this project, as directed by the initiative for DOE, we looked at the primary goal of recovering rare earths and critical minerals. Secondary was to manage feedstocks and especially focus on those feedstocks for carbon ore, carbon engineering, graphite, those carbon materials. Tina is about to talk about a lot more of that. And then the third goal is all remaining mineral material. Like we want to use the entire product if at all possible. Next slide, please. After quite a bit of resource assessment, what Bob touched on, we've shuffled that a little bit. So right now we're focused on exploring feedstocks for carbon ore potential. One reason we've shifted that a little bit, it's been difficult to find predictable occurrences of critical minerals in these coals. I touched on the diversity of coals from coal mine to coal mine, and even within the coal mines, individual seams vary quite a bit, as the miners here today know. So setting up a technology innovation center pathway based on rare earths and coal already has some problems if you think about how variable that feedstock is here. The strength is that variability in coal provides us a whole multitude of carbon engineering, carbon ore potential products. The waste streams from processing those coals to produce those carbon ores have the metals we need. Those can be combined, potentially combined feedstocks, whether it's rare earths or other critical metals. So both are primary goals, but we've shifted the focus a little bit. So our second round of sampling to the coal mines, both Colorado and Wyoming for this project, we're looking at the coal properties themselves for carbon engineering now that we have better understanding of the metals already there. The challenge is the value and how to extract economically. That's a list of all of the materials we have to assess. I didn't include it in this slide deck, but we have what we call the spaghetti diagram. It's the source to the end user and all the lines that interconnect this complex list of critical minerals through the entire supply chain. And it's a total disaster to try and figure out. That's why we're trying to insert an energy economist into this to help finish this project off. So there's a lot of decision making, but with the criteria in the matrix we've designed into this, that can assist us there. So we're not just throwing darts blindly. Economic evaluation I've touched on. That's a huge part of where we need to go in the next phases of this. We did assemble this initial criteria. These weights could of course be adjusted to meet a regional or a coal basin specific needs, depending on projected lifetime of a coal region, changes to industry. We know in this area, Trona is starting to increase production. They're opening new mines. Coal is declining. So you can move these weights around, but generally we're looking at both short-term, short-run local economic benefits and balancing those with long-term. We don't want to stand up or propose standing up new innovations that would be short-lived. If we can stand something up that has immediate economic impact and has a proposed long lifetime, that's all the better. Of course, with the volatility in critical minerals, that can be hard to predict. Return on investment, job creation, minimal environmental impact all play part of that. But again, this is a shifting matrix to meet the needs of wherever we're inserting this to make these decisions. So some of the areas we've preliminarily identified are listed here. The AGNC put out playbooks. This is maybe a year and a half ago. It all blends together now. We've been on this project almost 3 years, I guess. 2 years ago, these playbooks were released. So one for Colorado, Northwestern Colorado, one for Utah, where obviously some of these Colorado coals are going. We found some parallels to those playbooks, particularly the carbon ore manufacturing and the rare earth and critical minerals extraction for some of those carbon ore processes. So extractive metallurgy, that includes those non-coal materials, phosphates, tronas, the black sands we've identified in the resource assessments. And development around the EV components industry. So Richard spent a lot of time before he retired earlier this year visiting with companies and entities in Colorado to talk about the emerging EV components push you have here in Colorado. So that includes rare earths, that includes graphite, that includes vanadium, all things that this basin has a natural resource. So we want to focus on that. Can you produce the graphite from a coal regionally rather than import it from somewhere further abroad? Is it a Colorado-based industry that we can suggest based on natural resource availability? And other rare earth and critical minerals goods production is a focus. The map that Angela showed, the mapping tool that we're expanding into regions, we're looking at advanced manufacturing on the Front Range of Colorado, in Utah around Salt Lake. We're going to extend that map as far as we need to This is where the natural resource potential in this region can be extended to advanced manufacturing and downstream supply chain development. So location considerations, DOE has asked us to propose locations for technology innovation centers development. At this time, it's pretty difficult to do. We have a ton of location potential depending on which pathways we choose. This is a brief list. There's a lot of other places we could list. So is it on-site at a mine? Is it repurposing infrastructure at a power station as they close regionally, or is it something else? Right now, we're leveraging the colleges. Quite honestly, this is a big part of including the colleges for this purpose. We're looking at this as sort of a hub and spoke with those community college locations in the region as the centers for those hubs. And you can insert into those what you need to make technology innovation possible regionally. That may change, but that's our approach right now. And next slide, please. Okay, so I'm off the spot. I think that some of the uncertainty in standing up technology innovation centers is best solved by following existing models. And I again, don't want to brag, something that the School of Energy Resources has done very well at technology innovations around coal products. So Trina is presenting on some of those developments today, and we hope to use some of those lessons learned in that model in the Corsium project for this region.
Good morning, everyone. So I'm the director for the Center for Carbon Capture and Conversion at the School of Energy Resources. And I've been the director for about 1.5 years. I took over from Richard Warner, who was the prior director. And the carbon engineering program started in 2016. And what the whole idea was to, through different types of technologies, to leverage coal resources and competitive strengths to provide a sustainable way for the coal industry and coal in general. And so one of the things that we looked at was non-energy opportunities for coal. And in our center, we decided through various trial and error, so the lesson learned was, for us, don't decide that you're going to use a particular coal for everything, because a particular coal isn't going to be good for everything. Each coal will tell you kind of what it can do. And so our focus was Powder River Basin coal. And so the 3 areas that we actually have developed and are moving into some kind of a commercialization piece of this are high volume emphasis products. One is asphalt binder, another one is building materials, and the soil element. So those are the 3. We have 9 areas of research, 11 total with the 2 processes that are upstream. So I'll talk about that in a little bit. The other thing that we're looking is growing the presence of Wyoming coal and thermal markets. And that, when I say that, it's mainly clean combustion. So we're looking at different types of technologies and maybe a newer type of coal combustion power plant. So that's another area that we're looking at. Next slide. So as I said, the carbon engineering program started in 2016. We would not have a carbon engineering program if it was not funded by the Wyoming legislature. They have funded us completely for this entire thing, which has been quite remarkable. They wanted to, they have a large amount of coal up there, and they wanted to see, okay, what can we do with this other than they were seeing the decline of coal sales, so they wanted to see what to do. So they came up with this. In 2023, they're still helping us out. We have 11 areas of research, like I said, 2 upstream processes and 9 downstream product areas. And 3 of them I talked about earlier. The 3, asphalt binder, building materials, and soil amendment, are the ones that are kind of moving in a more commercialized way right now. The other ones are coming along, but we're not there yet. We also, in order to prove the technology, are building a field demonstration plant in Gillette, Wyoming for the upstream processes, which I'll talk about the upstream processes in a minute. So, and so just to give you an idea of relative size, the projects or the pilot plants that we have at the University of Wyoming are in gram to kilogram scale. And the field demonstration plants in Gillette are 600 pounds an hour plants that are going to be running continuously. So they're quite a bit larger, and they're basically the plant that you would build right before commercializing the plant. So we're trying to gather engineering data when we build these plants. So next slide. So the upstream process development for us has been solvent extraction and pyrolysis, and these are our two pilot plants that we've got at the university. The solvent extraction, one of the takeaways with solvent extraction started out with using a solvent, tetralin as a solvent, which is hydrogen donor solvent. And we, what we do is we start bench scale, and then with the solvent extraction, what we did was we did a semi-continuous, meaning we loaded the coal into the reactor and then ran the solvent through as a continuous. So it was semi-continuous. And what we found was, number one, from the economic standpoint, tetralin was not going to be economically feasible. So all along, what we've done is we start with the bench, and then we move to pilot. And then when we get pilot data, we do a techno-economic analysis to see, is this viable? Is it not viable? Do we need to change the design a little bit to make it more economically viable? Because just because you have an idea doesn't mean that you can scale it up. So you have a lot of different things that you have to do in order to be able to scale something up for commercial. So we have a couple of process engineers that are on our team that really look at each process and try to figure out, okay, if we were to scale this up, what would it look like? And so they get in there right at the very beginning and help us with the design of some of these things. So, okay, so one of the things we have is a coal-derived asphalt binder. And one of the things that was very surprising to us about the coal-derived asphalt is the CO2 emissions comparison between petroleum asphalt, which comes from conventional crude, and then our coal-derived asphalt is 3 times less upstream CO2 emissions for the coal-derived asphalt, which is something that is becoming very important as far as you know, the carbon negative, carbon neutral type feedstocks people want. So that's one thing that has come out of this is extremely surprising to us, actually, but it's positive for us. So next slide, please. Okay, can you do the next one? Yeah, okay. So one of the things with Powder River Basin, I realize we're not talking about that in this area, but I just wanted to point out that for this, if we're doing Buy America and we want to keep things in the country, these types of things are very important. And as I said, Powder River Basin coal can be used to make the asphalt binder, but that doesn't mean that other coals can't also be used to make asphalt binder. So I'm just pointing that out. So next slide, please. One of the other things we have is a brick. Okay, so okay, I talked about solvent extraction. The other big process that we have, the upstream process, is pyrolysis. And what comes out of the pyrolysis is coal char. And what we use the coal char for is a whole bunch of things. One of them is building materials. One of the things we're doing is some of the building materials. And one of them is our coal-derived brick. And Dominic, can you pass those around? So we have a brick, that's a coal-derived brick. And then we also have a standard brick. And if you could just pass them around so you can hold them and weigh and see how much they weigh. One is like significantly less weight than the other. So when you actually were to transport these bricks, transportation costs would be way less. It's one thing. People are asked all the time if they catch on fire. Since they're char, which is primarily carbon, they do not catch on fire. As a matter of fact, we did a fire test and they have a Class A fire rating. So that's pretty cool. They're half the weight of a traditional brick. VOCs are lower in the char brick than the clay brick. And the CO2 emissions are lower too. And the reason they're lower is we do not use a kiln to cure them, they're cured naturally. So anyway, so this is another area of research that we're working on as well. Next slide, please. And we have built 2 houses. One is a char brick house from the bricks that you see there, and then the other one is a conventional clay brick house. And what we've done over the last year is monitor each house for the VOCs and the CO2 and the weather, if they're warmer on the inside in winter or the summer and that kind of thing. So we have a lot of data because they're right next to each other. So everything is the same. So come up to Laramie and I'll give you a tour. It's really cool. Okay, another thing that we have available is soil amendment. This is something that could really be big potential for this area. What we have found, we're in our 3rd year of field trials with our soil amendment. And what we have found is with the soil amendment, which is essentially the cold char, essentially, it helps with water retention in the soil. And it also helps with nitrogen runoff, and then improves crop yield too. So what we're doing right now is analyzing the crops to make sure there's no uptake. We've done an analysis on the char, and there really are no heavy metals in the char, so we're not really expecting anything, but we're doing our due diligence to make sure there's nothing there. The other thing we're doing is we have another project that is a bioreactor setup where we had a principal investigator go out and get a bunch of algae that is unique to Wyoming, and this is terrestrial algae, and put it in the bioreactor, and that algae really loves CO2. So we're taking our pyrolysis gases and running them through that bioreactor to get rid of the CO2. So we're really trying to make the whole process net carbon zero. So that's another thing we're working on. So next slide. These are some of the other things that we have worked on, that we're in the process of doing. One of this one, the geo with concrete geo, is graphene oxide. We had a sophomore work on a project for the graphene oxide, and he said, well, what if we put the graphene oxide in concrete? And so we thought, oh, okay, well, we'll try that. So I was Jacob Chadwick. Anyway, so we tried that, and if you put in just 0.05% of graphene oxide in the concrete, it increases the concrete strength by 27%. So it's like, okay, so things are happening. People are thinking about what you can do with coal. There are so many options out there and so many ideas that I think we can together come up with a whole new industry of coal-derived products that are not thermally based, right? So I just wanted to point out, we're working on these things. There are other things that I don't even have on here. One of them is we also have a graphite project, hold a graphite project that we're working on. And we're also taking, we have on our solvent extraction, we have the extract that comes off the top, which is for the asphalt binder stuff. The residue that comes out, we're using that to do some concentrated rare earth element analysis to see if we can extract the rare earths out of that. So we're trying to use every little molecule of the coal as well. Next slide, please. So some of the other areas that we're thinking of moving on for next steps. Let's see, I think Mines is working on the bioleaching, right? Is that right? Yeah. And we have this particular idea here, the fabrication of carbon doped membranes. That's something that we're thinking of working on. That could be something that this area's coal could work on, or could maybe be a really good advantageous player there. So these are some of the things that we're looking at in the future. And since we were working on high value or high volume products, the reason for that is Powder River Basin coal is just everywhere. So that's one of the reasons we were working on that. There are high value products too that are extremely important that we are working a little bit on, but that area is just, there's so much you could do with that. There's carbon fiber there. I mean, there's a whole lot of different areas that you can work on for that. So anyway, so that's what I have. You're welcome.
Part of our resource assessment strategy has been to take coals from all the participating mines and provide composite samples, those production samples, so you wouldn't have to change mining practices. And we're supplying those samples to Trina's group for testing. So in addition to rare earths, we're trying to understand all those coal product pathways. Our next presenters, Christine Reed, our Director of Outreach for Community Resources, and Kyle Summerfield, who is the Director of our 3D Visualization Kit. We'll talk about stakeholder outreach and education. There's a lot in this project to digest and provide stakeholders, and they're doing a tremendous job at that. So, thanks.
All right, thank you. So you can go to the next slide there. So as you mentioned, I'm Christine Reed. I'm our Director of Outreach. I am a co-task lead with my colleague Kyle Summerfield here, who is the project manager for our 3D Visualization Center. And in task 7, we are tasked with outreach and education. And thankfully, you're all here as a product of our amazing partnership on this task with Colorado Northwestern Community College. And then our Wyoming partner is Western Wyoming Community College, who hosted this event last year. So without these folks, we couldn't make our way out into the community and reach the people that we need to be talking to. So thank you so much. You can go to the next slide.
Great.
So kind of the objectives of this task are to take all of this information that you've been hearing. I don't know if you felt a little bit like, wow, these people are really smart, but I don't know what they're talking about this morning on some of those things. So kind of our job is to kind of take some of that stuff and make it into an accessible form that we can actually engage with members of the community that maybe have zero science background whatsoever, never heard of a critical mineral element. So we're trying to find a lot of like easy, accessible ways to engage with our community members, and that may be through, you know, some of our like handouts or our website, things like that. We've also gotten more sophisticated, Kyle will talk about on his side. But anyway, we want to make sure that people are getting information so they can then make informed decisions. I think, you know, Selena talked about all of the important conversations we need to be having. Our task is kind of how do we actually, you know, execute those different conversations. So another big important aspect of this task is to kind of assess the existing resources and infrastructure that we have if and when a rare element and critical mineral industry could ever get off the ground here. So what kind of workforce training programs do we have in our community colleges? What sort of programs that we can already utilize or easily transition over into this new industry? So we're taking a look at what we have and then also identifying some of the gaps that are there, not only in what we might need to execute a new industry, but also in communicating. So technological era, we do a lot of webinars, we do a lot of flyers, we do a lot of emails, but that doesn't reach everybody. And so I know Selena talked about her social license kind of survey. That was a really important study because that also kind of let us know who we're not communicating with. So we want to make sure that we're making sure all of those people are part of the conversation because they're all going to be affected when our communities are going through different periods of transition. So, and then from there, after we know who we're talking to, what gaps are there, we're going to be able to make final recommendations and a final product. So, next slide. So to date, just some of the accomplishments and things that we've done. As I mentioned, we do have some of these resources out there. We have handouts. I'll talk about more, which are great. We've done a lot of webinars that Selena also mentioned in her video. Those are all publicly accessible on the School of Energy Resources website and YouTube channel. So I go back often and look at those, especially you're going to hear from Amy next, but the workforce development webinar we did was just phenomenal. There's so much out there. So that's been really great. Of course, the annual forum, this has been a great opportunity to meet with a bigger group of stakeholders and really diverse stakeholders on both sides of the border. So that's been good. Collaboration with other core CM projects. This has been really, really easy for us to a certain extent because we have two. So we've been able to duplicate a lot of our efforts in both Powder River Basin, but also in the Wind River, the Greater Green River Basin. And that's great. But I did want to point out, we have reached out to other projects. Dobbin's been really proactive about communicating with folks in Utah. We also invited a professor to campus. Charles Sims came to our distinguished speaker series at SU, and he's a PI on the Appalachian Forcium, and brought this really amazing perspective. He's an economist, and that's something that I feel like we've been a little lacking. Just we haven't had the people on our side. So really great way that we can kind of see how we can work together, because this isn't just going to be isolated from one basin, it's got to be nationwide. And then again, expanding our contact list. We are just working to get out there and talk to as many people as we possibly can, which actually that reminds me, if you showed up today and registered on site, come see me before you leave and make sure I have your email address. So if you want to stay in contact with us, make sure you get all this sort of things. Next slide. So one of the things last year we talked about was a makerspace badge that we developed. So again, using existing infrastructure, there's this really great program on campus called a makerspace, where you can go in and get basically micro credentials. And so we have created one of those micro credentials, just a very high level. What is rare earth element, critical minerals? How do we process it? So these are just some examples of some of the graphics that we've done to kind of break down what does this entire supply chain look like? What does processing separation look like at a very high level? These are inside that makerspace badge. So just wanted to kind of give you a little visual there. So, identifying gaps. Last year we mentioned one of the biggest gaps that we've identified is communicating with our tribal nations. And so obviously the Wind River Basin on this project, we're working with the Northern Arapaho and the Eastern Shoshone tribes. And so since this time last year, made a real concerted effort to actually make it out to the reservation, kind of talking about those communication methods. They're very oral, like they like meetings in person. So we've made efforts to go to their community events on the reservation and speak with them. We went and saw this video. It's on YouTube. The link's in here. You can get it too. Just really eye-opening. It's really important to see what sort of values they have. Distrust, honestly, of some of past history and projects. And so we're finding ways to provide information and options and have like actual meaningful conversations when it comes to any sort of project that we're doing with. We have really great collaborative efforts with the High Plains American Indian Research Institute at the University of Wyoming, Hapari. And that's just been something, looking for long-term ways in which we can integrate kind of energy education and tribal education into our curriculum. So we're working with like cross-listing classes, but also looking at recruitment for their students so that they can come and be a part of our opportunities and then go back to the tribes. And then we are creating resource guides too. So we are currently working on something just to kind of show, if you had interest in developing rare earth elements and critical minerals, where would you even start? So I have a law student working on what are kind of the steps for permitting on tribal lands as opposed to non-tribal land, and what sort of funding opportunities are there, and how would you even go about getting them? So I think it's really great that we talk about all these different things going on, but it's a little bit paralyzing when it's just a lot of information. So we're trying to be really mindful about something that could actually lead to a good conversation. So I think that might be me. With that, I'm going to pass it over to Kyle, who has the really cool stuff to show you.
I'll sum me up like that. Okay, so again,
Sorry. No, this one.
That'll be the first one. And then you can just set it up and wait just a second. Yep. Gotcha. Yeah, we can meet that. Yeah. So again, I'm Kyle Summerfield. I'm the program manager for the 3D Visualization Center at SER. It's nearly my 2-year anniversary as the manager, but I've been at the facility for almost 10 years in different capacities. So I've been developing for a bunch of different platforms for a long time. The center was originally built around a 4-walled cave, which you'll see in this video. This video is approximately chronological, and you can kind of mark that by the migration of hair from the top of my head to the bottom of my chin in these videos. So this is just kind of an intro to the visitor. So let's run through this real quick. So that's the cave on the left there, our power wall on the right. That's a subsurface map of the state of Wyoming. There I am with less beard. Educational outreach. This is for research purposes. This is our new mine safety training program that we put together for Gillette College. It's an MSHA funded program. This is our 360 camera and some material from it. This is one of our outreach applications. And another trend that you'll see in this video is migrating from dedicated big VR installations to consumer products. So focusing on web deployments, mobile deployments, and also consumer VR headsets. This is our structured light scanner. The idea being that if we need to capture extremely high fidelity versions of whatever's in the field, we can do that using that device. And as you saw with the last turnaround, which is a little tongue in cheek, that's our new employee, also named Kyle. But that's also a large scale scan. So we can do very large equipment with that device. Okay, this is the other video. So if you can pause it just a second. My intention was to do a live demonstration of this, but I couldn't get my laptop hooked up. So I recorded the video stealthily over there like an hour ago. So hopefully this works out. I'm going to cover all the features that we're fitting in here. We're looking at an in development version of the application I'm running on an emulator. So, go ahead and hit play there. So this is just kind of the overall structure of the app. It's made of tabs and pages. So right now there are 3 tabs, which I've populated with data that is relevant, but not maybe exclusively relevant to this meeting. But I want to demonstrate all of the features that are in here. So we can embed various things. So here's, for example, a speaker series that I've included here, which has embedded YouTube links. So we can keep that all in app without popping you out. If you need to pop out, it can as well. Just proving to you that it's working here. So let's see, where am I going to jump at? Okay, so if you could pause for just a second. This is our content authoring interface. So everything that's deployed to that app is easily put together through this little CMS that we've put together. Large, impressive CMS, I need to say. And there are several different file types here. So we have tabs, articles, uploaded files, and then kind of global settings. So we'll walk through each of those. So here's an example of all of the articles that we've populated, and I'm going to make a new one live here. All of these fields will warn you if they're not populated. You can set the publication date to the current time, or you can set new post date or schedule publications that way. Here I'm showing the tagging system. So each of those tabs can kind of accrue any tagged articles. So it's very easy to set up additional tabs or categories. So I'm making a test tag here. Which is now populated. And here we could upload images if we want, but there's also a guaranteed reusable library that you can search through by topic or color. It's important to comply with various ADA accessibility regulations. So here you must provide alternate text for every image so the screen readers can provide that to people who need them. And the caption is optional, but if you can include it, it'll elegantly handle not having one. So consistent capitalization is important. So down here, you can add as much text as you want. It'll handle a bunch of different formatting, common markup languages. We can also embed things. So I showed that YouTube embed earlier, but we can also embed Sketchfab, for example. We're the 3D visualization center, so we make a lot of 3D models. So we want to be able to show those in the application. Here I'm showing you where I'm sourcing this. So these are all scans that were done at the Geology Museum at the University of Wyoming. And let's pick one here. Grab the embed link. I guess I'll show you that it's really 3D first. And then we've set up a little mutator to take that embed link and format it how we need to show it in the application. And now now we've created a new article with content and we need to post it to a tab. So we can pick any of these tabs or make a new one. And this is all set up for you as well, for the person populating the information as well. You can provide custom SVGs, which are these image files, or similar to the kind of Splash library that we provide, there's a library of icons you can use. So here you can see this is a custom SVG, which is the Greater Green Basin shapefile. The modal is like, I don't show this later, which I should have, but the modal is like there's a little information button on top right you can click and it will give you whatever detailed information you want to contain there and not in the title or subtitle. And so we pulled in that tag that we made earlier, so that will automatically populate with the article that we made. And I'll pull in another tag just to show that it pulls from whatever pool you now want to use. In addition to populating by tags, we can individually add articles. And one thing I didn't show there is we can also pin articles at the top by priority. So this is that SVG library I was referencing before. We can search by topic. And then we associate a gradient with each tab to kind of differentiate each one. And the icons will pick the color from the bottom of the gradient, which you'll see in just a second. The whole thrust of this project is, rather than there being an email list that you may or may not, that may just get like filtered down through the emails that you are busy paying attention to, this can push notifications to your mobile device so that if you are particularly interested in this topic, you just have a subset of relevant information. There's been a big push to embed a variety of different information types. So if anyone has suggestions for different web apps that you'd like to see supported in the app, I'm happy to take them. So when I refresh the app here, we can see that we've got our new tab and it's obeying it's been colored according to the bottom of that gradient. There's the article we made earlier in this demonstration. And here's that 3D model running in the app without having to go out to an external browser or anything. And I think it's the next one I jumped to. Oh, I add one more article. Okay. 2 more features I'm covering. I'll foreshadow one of them. So each of the articles has a version history. So if there's some typo or there's a mistake or you change the article, I think we're tracking them for 2 months right now, but there's a version history here that you can always roll back to. So here I've manually populated this test article that I made last night in the hotel. And this we just got in development, just got this working last night. This is a live embed of an Esri map. So we can now just that'll run right within the app. No need to download a separate application or pop out to a browser. So all the story maps and stuff that other people have been talking about, we can embed right into this application. I think here is where I show the version change. Yep, so we added that additional details text, but maybe I don't want that. So we can roll back to the previous version that I had. And when we refresh and load that article, it reflects the reversion. So Broadly speaking, these are the features of the app as it exists now. We're still developing it. So again, any features that you think might be useful, I'm definitely all ears. And that's me. Are we doing questions now or later?
Thank you, Kyle. We had questions after our next speaker, but we had a minute or two. We can deal now. Just go straight to lunch after our next speakers.
Oh, made it easy on me. Great.
Okay, so that concludes our updates on where this project has gone in the past 2 years and the things we're currently working on. And we'll be working on in this last 6 months of project performance. As I watched the different task leads and experts present, I realized we have a heck of a team here. It's pretty awesome to see all this. This is actually the first time I've seen it all presented one after another. They're normally these separate Zoom meetings or things we have, so that was great. Pivoting towards a regional perspective and planning for the future, I wanted to finish this session with a regional perspective expert, and that's Amy Murphy, who's the Dean of Outreach and Workforce Development at Western Wyoming Community College. She's been a tremendous asset to this project in that workforce development planning. I know we'll do a lot more working with Colorado Northwestern Community College, and then in the next phases, additional community college. We hope to bring in experts like Amy, but she has a very nice regional perspective on this. So happy to have you. Thank you.
Good morning, everybody. So I am also going to talk about a critical element during my presentation, which is the human element. So I'm going to talk about workforce development in a changing world and why it's important. So go ahead with the next one. So the piece that I want to talk about with workforce development is there are objectives to it, right? Why do we need to have workforce development? What's the important pieces to it? And if you get us up here, you can kind of read through these, but it's actually building the talent pipelines, right? You have to have that human element, and you have to be able to remove those barriers, expand your labor force. And I don't think there's an industry out there right now that would tell you that they're having an easy time finding workforce, right? It's a huge challenge for everybody out there. And it's important that you actually have a plan in place, because as Selena mentioned earlier, we talked about communities and we talk about the whole base. And if those plants close, what happens to those communities? What happens to those workers? And we need to figure that out and kind of stay ahead of that. Go ahead with the next one. So I mentioned to you the piece I'm going to talk about is the human capital, which is the key asset, okay? So when you think about a workplace and you think about it, it's the humans that actually is what kind of makes that workplace vibrant, alive, and everything. So it talks there, we're developing, attracting, and maximizing the potential of people. What I'm going to share with you in the next few slides is actually from the State of the Global Workplace 2023 report. Now, I know you guys might laugh at me, but see, I nerd out on stuff like this. So this report here actually talks about different things that is happening in the workplace in relationship to this. And I'm going to show you the next 7 slides here, and I'm going to go through them fast, but it'll kind of talk about what's going on out there in the workplace. So there was this thing that happened back in 2020. It was called COVID. Wyoming didn't have the impact that I will tell you that I think some of the other states had. I came from Illinois, and we were in lockdown in Illinois. We were in lockdown for a long time in Illinois. And you're going to see as we start going through some of these things, some of these impacts really did impact those individuals in Illinois. Wyoming, you guys kind of kept things going, and kind of you guys weren't out of work as long as like some of the rest of the country. But when you look at this, the first thing that it talks about is the percentage of employees thriving at work reached a record high in 2022, okay? Do you notice what the percentage is? It's 23%. That's pretty low, right? That's the highest it's been on Gallup poll in the last 20 years. That's kind of scary. And we have to kind of look at that and figure out how we're going to work through that. Next thing that they mentioned was the majority of the world's employees are quitting quietly, okay? Now, when you look at that, talked about that 23% is thriving at work. again, some of you in this office or in this room know me pretty well. I absolutely love what I do. I heard Trina say it over there after her presentation that she loves what she does. Do you hear that a lot from people? Like, I love what I do. I absolutely love what I do. And this to me is like a lot of fun and kind of doing this kind of stuff. Every day is different for me because I work with business and industry and I work with all industries. So you're constantly learning something. And to me, it's a challenge to kind of try to figure things out. What's scary is the other two numbers. So you got quiet out there. Those are the employees who are not engaged, that are just kind of sitting there. And for whatever reason, they haven't been embraced into the workforce and they don't really know what their purpose is. That is a low-hanging fruit. And you'll find that out later, that we can actually kind of look at that and kind of enhance that. The loud quitting, many of you probably know somebody in this category who is just kind of that disgruntled. They felt they were wronged by leadership for whatever reason. And everybody tends to know they're there and they don't like their job, and kind of goes on. Go ahead. So as we went through this, we talked about the pandemic, we talked about COVID, and we talked about the daily stress aspect of it. If you actually look at the question that was asked is, do you experience the following feelings during a lot of day yesterday? When they talk about that and they talk about the level of stress, everybody has that high level of stress. A large part of that was provided through COVID and that uncertainty of what was going on. You know, they don't know what to expect. You're kind of stuck at home. I'm a people person and we were remote and I absolutely positively hated it. I hated the squares, hated those Zoom calls. I hated them with a passion because I'm a people person and I want to talk to somebody and I want that human interaction. But that stress level of constantly the unknown, right? That is occurring and it's still there. Go ahead. In 2022, the world experienced a widespread resurgence in jobs. Again, going back to COVID, there was a lot of layoffs, right? A lot of places were shut down and people were there. Back in 2022, as you can see it, we're starting on the uptick. Now, what's happening though? Where'd the workforce go? It's not there. You can ask pretty much any industry out there, they're not finding the individuals. So even though it's on the uptick with the jobs, where's the workforce? And that's the piece we're going to kind of talk about a little bit later on here. So again, over half of the employees express some level of intent to leave their job. Now, this is kind of scary when you think about this, because when you get the workforce, you don't want the workforce to leave. So why are they looking at this? That's the piece when you start looking at that they're actively looking because the job market's on the rise. They're looking at that. I've been here in Wyoming 2 years, and I always share this story. We had a large center modal that actually had a lot of distribution centers that opened. One would open, people would run across the street because they made 25 cents more an hour. Now, they might not have gotten the benefits they had at the last place or the hours that they had at the last place. They were looking at that mighty dollar and they would leave. And it was that constant like hopping. That's what's kind of going on right now is people are looking at the opportunities that are out there. They're kind of pitting people against the others. So 51% are currently employed, are watching for different opportunities. Go ahead. Going back to the engagement piece, and this is actually extremely important. Engagement has 3.8 times as much influence on employee stress as the work location. If you are actually engaged in the workplace, it's less stressful. You kind of tend to kind of blend in there. If you kind of look at some of the different things, and it talks about the fully remote, hybrid, and on-site. What's interesting about these numbers, and when you start looking at that, I told you I'm a people person, so I want to be in the office, right? There's some jobs that cannot be hybrid. There are some jobs that cannot be, fully remote. But when you start looking at this, what do you notice? It's that hybrid category is where kind of you're seeing the excelling as far as like the different numbers and the kind of it's aspect of engaged versus not engaged and all of that. Those are the pieces that employers are now having to look at. Okay, go ahead. Back to that quiet quitting employee that's out there. They asked the question to those folks and they said, what would you change about your workplace to make it better? 41% said engagement or the culture. Okay. 28% said pay. What's the one thing you always hear people say they want is more money? It's in the middle. Actually, almost about a quarter of it right there. And then well-being is 16%. So those were what the report came out. Go ahead. And what it talked about here is workforce development, why it's necessary. And I'm gonna let you guys kind of read these, but just to kind of paraphrase what some of these are saying, like if you look at the first one, it's acquiring the skills and knowledge. Okay, that's the first piece that they need to enter the job market to be successful in their career. The second thing is bridging that skills gap. That happens a lot of times when you look at your industry, and it may expand, it may add on a new level, is bridging the skills gap from where they were to where they need to be. And that's providing that workforce development component. And the last one is that inclusive and equitable job market. Providing those opportunities for individuals who have those diverse backgrounds and embracing that. Go ahead. So this is another interesting kind of thing when you look at top 10 workforce trends. This should be absolutely really no surprise as you're kind of starting to look at this. Upskilling and reskilling is the number one thing. Okay, when you look at the coal impacted communities that are out there, and I don't want these coal plants to close by any means whatsoever, but I'm going to use the Kemmer area, for example, in Wyoming, but we have TerraPower that's coming in, right? We have the nuclear facility and we have the Naughton plant, and we're looking at the individuals at the Naughton plant to kind of transition them over to the nuclear so people aren't out of jobs, right? So what are we doing? We're upskilling and reskilling what they're doing. We're giving them those additional skill sets that will make them successful in their job over there. The remote workforce, again, that's a trend. Not all industries can support that, but remote workforce is really what's pulling people away from other places who do not want to go into a physical office. AI, this is huge. AI is really becoming more and more integrated into industry. You're finding it a lot of times in manufacturing, the distribution centers, all of that, incorporating the AI and kind of, it's not replacing workers. I was in a company trying to, we were working on doing some training development, and a lot of the workers that I was talking to is like, they're taking our jobs. AI is not taking the jobs because it's actually going to upskill, again, going back to number one, and reskill them to actually program that and kind of monitor that. You got the diversity and inclusion aspect of it. And then number 5, which is focusing on mental health. Okay, that has become more and more a play in the workplace anymore. And again, a large part of that mental health aspect of it has come from COVID. So continuing on just really quick through these, you got the empowerment of non-traditional workers, personalized learning and development. It's not a one-size-fits-all anymore. That's some of the things that had happened in the past. We're going to do some on-the-job training. We're going to do it this way. Everybody doesn't learn that way anymore. So it's actually coming up with different ways of teaching and training the employees. Embracing the digital transformation, again, going back to that AI component and other aspects to that. Prioritizing employee well-being. You're seeing that coming into play more so in the industries, bringing that on site and having those services available. And then the last one, again, is employee engagement, making sure that people are actually engaged and embracing what they're asked to do in the workplace. So I put this up because I thought this was really interesting, and I thought people might want to kind of see this, but this is actually an interesting workforce fact that's out there, and it's going to have a huge impact as we move on in future years. Non-traditional workers, such as gig workers, freelancers, and contractors, are playing an increasing important role in the workplace. What does that mean? That is, I'll use my sister, for example. My sister is, she does photography on the side for fun. She is finding out more and more she's getting called for individual projects. She can pick and choose when she works now. And she's looking at, do I want to do that and leave the job that I'm at? Because then I have a lot more flexibility. I have more freedom to go do things. This number is 24% of the people out there. And that number is going to keep rising. Again, because they have that flexibility, they get that freedom to kind of do what they want to do. Go ahead. All right, so what does all this mean for workforce? What is our opportunities and our challenges? We know the labor pipeline is changing, okay? We still know that. Do not laugh at this. I don't want to tell you because then you guys don't know how old I am, but I've been doing this for 30 years now, okay? And I'm 16, okay? I have heard this for the last 25 years. The baby boomers are retiring. Okay, I've heard it for the last 25 years. They're still out there. They're still out there. They're still working, but they are coming to that point where they are going to start retiring. So we've got that highly skilled workforce that is going to be leaving the industry, and all that knowledge and all that goes right with them, unless we do something about that. You've got the millennial generation who's coming into the workforce, right? Now, my kids would kill me for saying this. Some of my direct reports would kill me for saying this, but I'm still gonna say it. So the millennial generation is not the same as the baby boomers. Big shocker, right? They're not. The millennial generation, they want the flexibility. They don't care what your needs are. They want the flexibility. And I always used to, Cliff actually asked me this on the way over and he's like, are you into sports? No, not. So I apologize for that, but the Cubs would be in town in Chicago. Yep, I'm gonna call in sick. It doesn't work like that. Like you can't just like take off whenever you feel like, but that's what's happening. And if you're watching any of the trends with some of these corporate, they're allowing unlimited time off. California is actually leading that charge right now. My niece and nephew, I think if they've worked 6.5 months total, it's amazing because they're always on vacation. It's unlimited paid time off, and California is leading that. The millennial generation absolutely loves that. But then you also have this next piece, which is the mismatch in worker training. So again, remember, it's not a one size fits all. You have to look at the new jobs that are being created, what's needed to actually do those jobs. And again, going back to that upskill. The last piece that I found kind of interesting is the decreased birth rates. People aren't having as many kids as they used to. So again, where's the workforce coming from? And again, you got the employee engagement versus contentment. Okay, I'm just satisfied to be here and kind of looking into that a little more. So we got our existing and future workforce, okay? So you've got who's here, and then we got the ones that we need to get here, okay? So when you start looking at this, again, you've got to engage that current workforce, okay? You have to look at those quiet quitters and try and figure out how you can get them engaged so they don't want to leave. Make their job meaningful, that they have purpose there. You got the upskill to the incumbent workers, retraining individuals who are laid off from impacts, you know, like unfortunately from some of the coal impacted communities. You've got high school and college students to look at. You've got community faith-based organization, associations, chambers, economics. It's all networking and partnerships. And one thing that I share, like on the existing and future workforce, when you look at Wyoming, and I'm going to use the southwest corner of Wyoming, we have a next gen partnership, which is our Southwest Wyoming manufacturing partnership. We're actually hosting an event tomorrow to actually address this very thing, the workforce development. Where are we going to get people to fill the gaps? In Southwest Wyoming, we're anticipated a huge growth with the Trona mines that are out there, expansions of that. We've got the nuclear facility coming in. We've got other things in the construction aspect of it. Where are we finding all these workers, and how are we going to have them ready for when they need them? And that's a big piece of it, is the networking and partnerships. Go ahead. Now there's challenges, like with anything, with individuals. So you've got people who are displaced and they don't necessarily have transferable skills. You can teach them, you can train them. And that's an opportunity to find individuals like that and help them. You got that workforce age person who may not be in the workforce for a while. That was a lot of times, I'll call them housewives. I never did that, so I can't say I did that, but you'd have that where they stayed home with the kids, and now they're going out in the workforce. You're actually now seeing it's more the males who are staying home with the kids, and they're going out after, which is kind of ironic. But you've got those people who have not participated in the workforce, and those skill sets have changed from when they were in it, and it's bringing them back up to speed. Dealing with people with social economic disparities, that's a huge part of it, and you need to figure out ways to engage them and get them in it. My biggest challenge, I hope to achieve this before I die, it's a huge one, but the homeless population. There has to be something we can do to help those individuals get back into the workplace. Because if you go and talk to some of them, they actually were thriving individuals in the workplace. And because of unfortunate things that happen out on the street, there has to be something we can do to help them. There's a large number of those individuals. But you got people who are facing cultural barriers, disabilities, criminal records. That's a big piece now too that corporations are looking at, is those with criminal records, to try and bring them in, because they can provide different things. And that's partnering again with the justice system to provide that education while they're in there. And then you got the geographic and mobility challenges that are there, and then underemployed and unemployed, due to business closures. So what does this all mean? There's an awful lot of mismatch between jobs and workers. There's also a lot of communities that don't have necessarily a talented workforce. That's where we come in to kind of help play a vital part to this. Go ahead. You can do that through sector partnerships. Okay, I mentioned to you the one that we have. But if you take sector partnerships and you actually kind of look at what we're talking about here, as far as like all the different sectors that are out there, K to 12s, adult basic ed, community colleges, universities, community-based organizations, other countries track their students when they go through school and they track them. So you're going this way into engineering, you're going this way, and that is 100% what their education track is to get them into that. We don't do that in the United States, and that's totally fine. But we have to figure out how can we work together with all these different organizations to actually fulfill and find the solution to the workforce development and workforce shortage as a whole. Pieces that people don't know about, but there's workforce boards that exist in every county, every state. Those are individuals who are there to provide funding. And that funding can be used for training to help them get into a new occupation or into their existing and just upskill. You got Academic Development Association. Selena mentioned that again with the community, and you want your community, you don't want places to close and have that impact to it. So it's working with different folks to make sure you show the value added to it. Again, the collaboration is key. I mentioned to you guys about the workforce investment boards. That's the workforce services. I've got partnerships with four-year universities. I absolutely love what we're doing at Western Wyoming Community College because I'm very fortunate because I am part of the Core CM project, but I also work with Kyle on a VR project that we're doing throughout the state. Selena and I are on a blue hydrogen project together. It's actually really exciting and fun because to build those partnerships, and we can actually build pathways that go back and forth in education because we only go up to the 2-year. Now we do have a bachelor's in applied science and business, but for the most part, a community college is a 2-year program. So it's that stepping stone to actually go to the university. So for us, we're super excited. I actually got to talk to Holly about the nuclear tech hub that's coming in to make sure we're kind of in alignment on that because that's another piece that we have the opportunity for. And then you got public schools. One of the things that we have really kind of embraced and enhanced, and I'm going to really recommend this to the industry folks out here. If you have not reached out and partnered with your K-12 systems, you need to. These kids don't understand what the jobs are. And it's on us to tell them what they are. They don't know what these jobs are. They don't know the pathway to get into these jobs. They don't know it. So that is a piece that we've been doing at Western, and we've been working with a lot of the industry in our area and the different school districts to go out, bring the folks in so they can actually talk to about what these careers are. My daughter, and I share this one, my daughter actually, typical kids is what I would call it, don't listen to the parents, right? And I'm trying to like, see what are you interested in, kind of going through things, and she didn't matter what I said. She comes home from school one day. She's like, hey, I figured out what I'm going to do. And she tells me how she met with an industry person at the high school. And I said, oh, what are you doing? She goes, I'm going to do this operations engineering program. The exact one I told her about, but I didn't explain it right. Now, the sad thing is I developed the program, but I didn't explain it right to my kid, right? She did it. She's out there right now. She's an operator in a nuclear facility. She's 25. She makes $206,000 with a 2-year degree. And I share that because people don't know what the opportunities are. And that's kind of stuff because an industry person came in and told them what it was, told them the pathway to it. They did it. Go ahead. So these are different things that you can do as far as activities that are out there. You got the vocational training, you got the job search assistant. This is the piece I absolutely love too at the college because I can actually help our students because a lot of times our students have never written a resume. They've never done interviewing, and I'll do that with them. I'll do mock interviews with them. I'll actually help them write their resumes. I work with the industry folks. I send out the jobs that they have available. I collect the resumes, and please don't take this the wrong way, but if the resume stinks, I tell them that, and I have them come meet with me and we fix it. So they're not embarrassed. And to me, it looks better for us to have that showing. So that's a piece. We do the training with unemployed and underemployed. We do a lot of incumbent worker training. You would think once you're on the job, people don't need it. They do need it. And we do a lot of that kind of stuff. Job programs for the disadvantaged. Climb Wyoming helps females that are disadvantaged, for those of you who don't know, and need that extra help to kind of get off their feet. We work with them, and we're doing a lot of different programs to help them get into the workforce, into jobs that are high growth, high demand, that they actually can survive. You got recruitment and retention visits. Why this is important with workforce development activity is going out, and that's usually the academic development. It's usually folks from the county or the city or the municipality that's in the schools. We hear what they need. So Dana had mentioned about water and stuff like that, but we find that out, and obviously in Wyoming, we're having that as an issue with water, but we need to know that housing's an issue, right? How do we work collectively to try and solve these things? And then you got the internship, co-ops and apprenticeship aspects, which are all part of the activities. Go ahead. So the key to success, and this has been what I've done now for the past 30 years, and I can tell you, I truly love what I do, but it's knowing who your community is and what their workforce needs are. I told you I was from Illinois and I was from south of Chicago. My district that our community college was in, we had 1.8 million people. I am in Rock Springs, Wyoming, and I'm in Western Wyoming Community College's district service area, which is 5 counties, which is 29,000 square miles. It's not even a fourth of the population I had prior, right? So it's different, right? So you got to know it. I can tell you I can go anywhere I want right now in those 5 counties. I can't get in Rock Springs where I want to go because I have no clue, but I can get anywhere else in any of those counties where I want to go. But it's knowing who the employers are, knowing who the other key element people are in the community to actually partner with and work with, developing those relationships and strategies. That in itself is probably the most critical thing to workforce development. If you don't make those connections, you're not going to actually survive yourself. And my thing that I always tell everybody is to listen to what your employers need. One of the things that my education friends, please do not take this the wrong way. One of the things education does really, really bad is we like to tell people what they want. We need to listen and give them what they need. Last thing there is communicate. You guys all know education does work kind of slow. So it's just the key of communicating where you're at with progress on doing different things. Implement program and marketing plans. Those things change. And that evolves over time, and that's perfectly fine. Get the feedback and continuous quality improvement. It's connecting the workers to employers, and that's the key element there. I always go with the customer service approach, and again, I can't stress enough the partnerships, how valuable those are to have. Go ahead. So I'll leave you with this, because I know I stand between us and lunch. This is my final thought for you. So workforce development is not just about preparing employees for the future, but it's also about creating a better future for everyone. That right there is probably a very powerful statement if you listen to that. By investing in the development of your employees, companies can create a more productive, innovative, and inclusive workforce that drives success for both the employees and the companies. When you think about what we're here for today with the carbon or rare earth minerals, and you think about the coal impacted communities, don't you think those individuals are also thinking about what's going to happen to them? And these companies who are actually out there, who are there for the employees, they're forward thinking. They're already looking at that upskilling and retraining because those employees brought how much to them. And I actually agree with Trina. I hope these places don't close and they actually maybe shift gears on what they're actually doing. If we can start taking some of these minerals out of the earth and processing those, it's another avenue. Right? And that's what we're all here for today, because you don't want any community to suffer like that. So I leave you with that final thought. And with that, Evan, I'll turn it back.
Thank you, Amy.
You're welcome.
We stole 5 minutes of your first break. So unless there are key questions here for any of the experts who presented this morning, or any, we'll let you out the 5 minutes early for lunch. Okay, thank you all. Especially, it's Colo season again, I guess. So it's my pleasure to begin these afternoon sessions of dialogue. This is where we really hope to get feedback from all of you, do some future planning for Core CM. But it's my pleasure to begin this session by introducing the Executive Director of the School of Energy Resources, Holly Kripke, Dr. Holly Kripke, excuse me. Holly has been at SCR for a few years now as executive director, and I can tell you has fundamentally changed the landscape on how we operate in very positive ways, so. And she knows Cole very well. Thank you, Holly.
Yeah, thank you, Davin. Yeah, so thank you all so much for being here today and for the collaboration with so many of our partners from the survey, from Western Wyoming Community College, from Northwest or Colorado Northwest Community College. And it means a lot to us to have these kind of partnerships, including also with industry. So what I'm going to talk about today is opportunities to leverage technology innovation centers. And I'm going to talk more about our experiences in Wyoming and where we've had successes to date, anything we've learned to date, and continued opportunities for collaboration. So, slide. Okay, so just before I do that, the School of Energy Resources at the University of Wyoming is a very unique entity. So I'm just going to give you a little bit of background on that, why we exist, what we do at the University of Wyoming and across the state of Wyoming. It's a really good model for meeting our mission, which is energy-driven economic development for the state. And then talk about the technology centers around Wyoming as sort of a proof of concept of what you can do around innovation. And like I said, some lessons learned as well. So keep going. Like I said, our mission at School of Energy Resources is energy-driven economic development for Wyoming. So we're very mission-driven. You have a national lab in Colorado. Their national labs in America are very mission-driven. So we function very much the same way. And when we say in Wyoming, economic development can mean a lot of different things, right? When we say it, we mean revenue for the state and then jobs as well. So next slide. The School of Energy Resources was started in 2006 by the Wyoming legislature and the executive branch. And the idea behind it was to take a small amount of revenue from the state's energy and extractive sector, which really does support the state financially for the most part, and reinvest it back into that sector at the state's only four-year research institution, which is the University of Wyoming. So how we do that, a couple different ways. This is just a graph of how we use the funds that the state of Wyoming gives us to undertake energy and extractive work. And basically what you're supposed to get away from this slide is for every dollar the state sends us, even though we have our own internal research program, we have lots of amazing professionals here that you've already heard from today that are part of that program. Actually, most of the money the state gives us, we are a pass-through entity. And so we have a governance board that is separate from the University of Wyoming. It's called the Energy Resources Council. It includes two legislators, and it includes a representative from the governor's office. And then the rest of the folks on that board are either appointed by the governor or hold those roles by position. And the folks that are appointed are either subject matter experts in energy or energy sector executives. And that's how we keep focus on what the industry needs. That's fine. Don't worry. The way we divide up our research program, but one of the things I was going to say is that, there's all these incredible minds at the University of Wyoming, great faculty, staff, and students, but they can only work on academics, outreach, and research that they have funding to work on. So we act as a mini funding agency. We don't have the huge multi-million or multi-billion-dollar solicitations that you would see from the Department of Energy. But what we can do is give seed grants, maybe $100,000, $150,000 over 2 or 3 years. That's enough to get a student started, start a new area of research, and then we try to help direct the start of that research so it's focused on topics important to Wyoming and let the faculty go. So just as an example, we recently released an RFP on the Mowry. So the Mowry Shale is Wyoming's largest oil and gas, unconventional oil and gas reservoir. It's largely untapped, and it has some both technical and non-technical challenges. We put an RFP across campus. We had about $2 million to do that from the state. And the responses we got back were incredible, things that we had never thought of. So this is really a model that works, is just to put an idea out here. Here's our goal. Figure out how do we reduce risk and increase production from the Maori, and let folks pitch their ideas. So we had some really cool ones. So the way we organize our research program at the School of Energy Resources is into centers of excellence. When I say center here, I'm talking about not a location, but a group of individuals collaborating around specific topics. All the ones shown in yellow are run by our staff in-house at the School of Energy Resources who are focused on these topics full-time. So for example, Trina, who you heard from earlier, runs the Center for Carbon Capture and Conversion. Kyle runs the 3D Visualization Center. I, in the next panel, will be Fred McLaughlin, since he's not here, and he runs the Center for Economic Geology Research. So, but then the centers on the right-hand, your right-hand side of the slide those are all run by tenure track faculty across the University of Wyoming. So both models work. And so it's a really cool setup that allows us to work on, just as you can see, a really wide array of energy topics. Okay, so now I'm going to talk about something that's more on the side of physical centers that are around the state of Wyoming that are really focused on technology development. So, so this year, the governor of Wyoming, Governor Gordon, delegated management and administration authority of the Wyoming Integrated Test Center to us at the School of Energy Resources. I'm just curious, who's heard of the Integrated Test Center? Okay, that isn't from Wyoming. No one? Okay. Okay, so actually, the Integrated Test Center is a place to test carbon capture and use technologies. And it was stood up about 7 years ago with an initial funding from the state of Wyoming, Tri-State Generation and Transmission, and NRECA, the National Rural Electric Co-op Association. And so it's just set up as essentially a location where companies can bring technologies that they're developing related to carbon capture to this location and have access to actual flue gas, to utilities, to a host site that is, you know, flat. And it took a few years to get this up and running, but today we're almost full at the Integrated Test Center. So it's taking about 20 megawatts of flue gas, about between 20 and 25 megawatts worth of flue gas, and directing it to this test center for technologies to use. And they can test there for months or even years. So we have for the first time, a company called MTR Membrane Technology Research will be testing their membranes that separate CO2 from other flue gases. So that's a large scale pilot. It's a really big project. It's 10 megawatts, and it's the last step needed before commercialization. But this is really hard for technology developers to find a good place to test their technologies like this on their own. So I actually started my career at a company near Denver, and we were testing things like mercury capture and particulate control from coal-fired power plants, like novel technologies, new types of fabric filters. And those were a lot easier to get testing on because the amount of burden to the power plant was way less than testing a 10 megawatt carbon capture facility. So this is there to provide a neutral test site for technology developers, and it's one of 2 in the country. Adjacent to this I just wanted to highlight. I don't know if I would call it a technology test center, but adjacent to Basin Electric's Dry Fork Power Plant, where the Integrated Test Center is, we also have our Wyoming Carbon Safe project. So if you're not familiar with Carbon Safe, it's a program from the Department of Energy. It's focused on the research and development, including non-technical issues, to create commercial scale CO2 storage hubs. So we have the Wyoming Carbon Safe, which the School of Energy Resources has been working on just about the same time that the ITC was stood up, actually. And today, there are 2 wells completed to Class 6 standards. They're not permitted to Class 6 yet, but you can see that through collaborating and through these big Department of Energy programs, that you can make a real impact on the infrastructure needed for in this case, carbon capture and storage. The School of Energy Resources was also awarded the Sweetwater Carbon Storage Hub. So is in the southwest part of the state, Commissioner from Sweetwater. We're really excited about this. This is focused on providing emission reduction opportunities for lots of different industries, including our Trona sector, really important industry, not just to Wyoming, but the world. And our Trona is already lower carbon than what is produced internationally. So this would give it even more leg up in a carbon constrained world. We're going to have a differentiated product coming out of Wyoming. So really excited about this. It's a $50 million project. And we're working with a company called Frontier Carbon Solutions on getting this one off the ground. So just highlighting those as, and by the way, these 2 carbon safe projects are on either side of Wyoming's existing CO2 pipeline. So what you're starting to see is us building kind of the whole state as a hub for carbon management. Next. The other test center that we are a tenant of, we have nothing, we didn't, well, I wouldn't say we have nothing to do with it, but we're not the leads on creating this. But in Campbell County, it's the United States largest coal mining community. And so a group of economic development professionals from Campbell County decided they wanted to, as we see coal consumption declining for the power sector, they wanted to help invest and create an opportunity to develop a new test site, kind of like the integrated test center, but this is focused on all different areas. So rare earth elements and really kind of scaling up the processing technology. We will be testing what Trina talked about. So we're working right now to, with Wood Group to do a demonstration of a pyrolysis technology that makes the feedstock that's used for the char bricks that you saw earlier and the soil amendments and many other things that Trina talked about. So really, this is just a neutral test site. It was definitely built with a build it and they will come. That can be challenging. Luckily, so we will come at the School of Energy Resources, really excited to use this, but I wouldn't recommend, standing up a test facility without an anchor tenant, which in this case, we kind of will be that anchor tenant. So it's going to work great. So. Next slide. And then also I wanted to highlight, you've already seen some of the capabilities of the 3D visualization center that Kyle leads, but this is a different kind of technology center, obviously, than the others that are just to test technologies, but really proud of the work that Kyle and his team have done collaborating with our community colleges, particularly in Gillette, around surface mine training, but there's so many opportunities around really great visualization technology and collaboration. And the other area that I wanted to highlight is just the ability to explain some of these complicated energy technologies to the public. So we're really excited about that. And this is another, I would say, a different model for a technology innovation center. So, and then of course, at the end of the day, there's always outreach, communication, and education. So I've talked a lot about carbon capture. Wyoming is really doubling down on that technology. We have a lot of reasons to do that. It's for our legacy industries, and we have the right geology. We have the right regulatory structure. We can make money and jobs off of it. It's just a lot of reasons. So now we need to focus on workforce. So we've stood up the nation's first undergraduate certificate in carbon capture, use, and storage. We also host a number of workshops like this one and all kinds of other things. So that's all led by our outreach professionals, Christine and Sabrina outside the room, but always trying to figure out how to be engaged with all different stakeholders. So, okay, so I think that's really all I had. And I had all these notes that I never looked at. So I just want to make sure I said everything I wanted. Oh, so I will say, when we think about, for example, carbon engineering, which is coal to products in Wyoming, we think really big. Like millions of tons. We would love to get to tens of millions of tons, at least 10 million tons, because we have the biggest mines in the world. And so, and the other issue that we're focused on generating revenue for the state, and the way our tax structure is set up in Wyoming is we have to produce more energy and minerals to drive more revenue. And for different communities with different tax structures and mines that aren't set up to produce 90 million tons a year each, you can look at things a little differently, right? So we have some coal to products areas that might not have tonnage, but might have big economic development impact for the community. So, and our work has been focused on the Powder River Basin. And I think one of the things that I want to talk about is that program was started in 2016. Today, we are doing the engineering to do the demonstration scale. So that's the last step we think we need to get the engineering data needed to build a full-scale commercial system. We still have to find investors. Obviously, we have to license the technology, getting investors. We're going to need that data. We're going to have to run the economics. We have work to do, but in 7 years is what it took us to get to the point where we're ready, we feel, to test at a scale that is the last step before commercialization. So if you're in an infancy with technology development, you know, all different technologies take time, but that's just one example of what it's taken for us to get from this is an idea, we want to create a new industry, getting incredible state support from Wyoming that wants to see these and new industries thrive, and doing the work to get to where we are. So I think that's it. I guess the last thing I wanted to end with was that we hope that you'll continue to consider us a resource. Because of our mission, we are focused on the state of Wyoming, but we are also we're definitely interested in regional partnerships. So we can bring in federal funding. We are always available to partner outside the state. So thank you, Davin, for putting this on. And thank you all for attending. And that's really all I have. And if I didn't talk to, I didn't at all. Okay. So I would be happy to answer questions if you have any. Yeah.
Questions? Okay, thank you again. I can't emphasize enough what Holly has done for these projects and energy resources in the state. We do look at these pathways that have been developed in Wyoming as models for these projects that go across state boundaries, like this course. And as Holly said, proposal development, those federal dollars that are out there, these DOE projects are expanding. There's more and more funding available for this type of work, for technology testing, for resource assessment, putting all these pieces together, community engagement. We helped AG&C a while back on just a grant on community buying for nuclear. Right? So again, we're available to help in those regional type projects with federal. So that opens up our dialogue sessions for the afternoon. We really set up the afternoon to spend less time standing here and talking and more time engaging with all of you in the audience today. We have two sessions we set up. The first is resources, mining industry, and technology innovation. So I'm happy to see folks from all those corners of three categories here today. Holly Krutka has offered to be chair of that as our director for the Center of Economic Geology Research is sick. Fred McLaughlin couldn't make the trip today. And we have two co-chairs for that. Mr. Alex Papp, who's a coal geologist that many of you know, and Dr. Jaehan Lee from Colorado School of Mines. And although this table is here, imagine that it's not, or we want to have a conversation. As the project lead for this effort, this is really an opportunity to gain information from all of you. Instead of the framework, how we move this project forward in the next years and years. Please take that. Right, thank you.
Okay, so thank you all for still being here. So today I am acting like Fred McLaughlin, because I did not want to ride here with someone who was as sick as he was in the car. So, so I offered to do his panel. So we have two panelists. So I think the idea is I have some questions here. And the focus of this panel or this dialogue session, it's not really a panel, it's a dialogue session. So the goal is to get folks to engage. And so the topic is resources, mining and industry and technology innovation. So I'll ask our two panelists to introduce themselves. And then I have some questions, but really would love to hear from you all and have a discussion around that topic. So with no further ado, Jae-Hong, can you introduce yourself?
Okay,
your background?
Hello again. Jae-Hong Lee from Colorado School Mines. I'm a metallurgical engineer, process engineer by training. I work for a gold mining company in Denver and Salt Lake City, Newmont and Barrick. And I studied at Colorado School Mines last August. Before that, I was in a little warmer climate in Tucson for several years. So my expertise is extractive metallurgy using chemicals, thermals, and biological, and I'm a new lixivians, and also recovery and a concentration and recycling in the different resources.
Thanks, Alex.
My name is Alex Papp. I'm a coal geologist. Started my career here in Denver back in 1980 with Atlantic Richfield, Arco Coal Company. I worked on some underground coal gasification, coal resources internationally as well as domestically, but focused in the Western US. My expertise is, mining, geology, coal quality control, and a lot of exploration. And I'm here to tell you, I probably described maybe 10,000 miles of rock core in my career. But I joined a team to help them predominantly for sampling on the Colorado side in particular. I've spent a lot of time at the Core Research Center in Denver, the USGS, collecting samples, also sample collecting at Colorado Coal Mine and Trapper Coal Mine. We just got an enormous amount of samples from those operations in particular. And that's
perfect.
All right.
Thank you. So just for background, one thing that might come up is the idea of technology readiness level. So if you're not familiar, it's just a scale that different federal agencies and industry use, where like a 1 of a technology readiness level is you have an idea, and a 9 is it's off the shelf technology, fully available, it's been deployed nth of a kind, and already gone through cost buy down curve. So that might be, I just wanted to give that basis for what the background for the discussion, because we might be talking about technologies that are at very different places on that technology readiness scale. So Alex, can you talk about we've heard a lot about different ways to use coal, carbon ore, rare earths, critical minerals associated with those. Are there sufficient reserves of minerals to advance some of the work that's being discussed here?
I think there is, to say the least. Greater Green River Basin is an enormous resource. From the tertiary as well as the upper Cretaceous sequence. give you some perspective, the Yampa coal field down here contains 16 billion tons of mineable coal, not recoverable coal, like I mentioned, PRB, but this stuff is, so we have a lot of reserves, but you almost have to look at it more on perspective of the coal mines that exist. What kind of reserves do we have? And that differs considerably from its grandiose amounts. Excuse me. And a lot of mines are positioning themselves for their potential closure, you know, start anywhere from 2026 to 2030. Seems to be the last thing I've heard of most mines, including at Bridger, shut down that power plant, or conversion that is, and shut down of the Great Power Station. Yeah. So when you kind of look at it, a lot of these 6 mines that occur in this area here, Bridger, Black Butte, Kemmerer, and down here we have Trapper, Colorado, and 20 Mile. These guys are the reserve holders, and they've been mining there for quite some time. All of them, except for Trapper, they're all surface coal mines that are operated on drag lines, truck shovel, loading of coal, and that's what they do, coal. We haven't really done anything with mudstone if we wanted to. It's usually a diluent that is not a good thing, but you know, that's one thing you have to look at. As new mines, as the mines are developing toward this new technology. 20 Mile, it's a longwall coal mine. It's the only underground in the region. It used to be one of the most productive coal mines in the world. Back in 8, 12-hour shifts, they were producing up to 10 million tons per annum. And right now they have their mine coal, which is a longwall move, and they have about 2 or 3 longwall panels left. Reserve standpoint, they're doing some exploration as we speak, and hope to add a little bit more reserve, but not a lot. They might have to actually, if they want to continue on pursuing markets, they'll have to start mining coal at their large reserve that they have already developed. They have portals in it. They have some mains developed already, so that could actually be ready to go anytime. Rapper mine, they're kind of reserve shy, but they keep finding additional reserves, especially in the western part of their reserves. And they have a large pit called L pit that they're actually getting a little deeper. And east of that, they actually have another chunk of federal coal that they opted to drop that. For a while, they, you know, I guess it was right 2016, they got a big federal lease, and Federal Register said that there was like 100 million tons of recoverable coal. Well, they just started mining that reserve, and Tri-State is telling that they will be closing in 2030. And they produce about 2 million ton a year, roughly, and that's going to just scrape a little bit of what's left. So they got roughly 80 million tons of coal that's right there. So they're kind of reserved, quite a bit of reserves, and they even have additional underground reserves in their surface. So for longevity, that one of that mine, 20 Mile, Trapper, less so. And for Bridger mine started to reduce what the mining areas themselves. They had an underground longwall mine that they stopped from getting additional federal coal a couple of years ago, and the mine closed. And now they're focused on down dip mining, and eventually they're going to be doing some high wall mining. And high wall mining and surface mining. Okay. But anyway, there's not as much that bazillion tons of coal that we think, but we have to keep that in mind. The other thing is, the mines that were there, they produced 13 million tons in 2022. And we're always wondering, what kind of tonnages are we gonna need for this new technology? You know, I don't know, you know? And some of these mines will be going away, you know, because of just the way things are on shutting down at power plants. But, you know, like I said, a lot of the mines that are existing do have resources that extend well beyond 2030.
Thank you. Jehan, what do you think are the most relevant technologies for GGRB workforce, regional opportunities? Like, what do you think the opportunities are?
Excuse me. So the other alternative is, I mean, I briefly mentioned, earlier in the morning, so we got to create some value-added products. So, I mean, that include, I mentioned graphite and a carbon for anode for different batteries. So, I mean, we most of the people talk about the metal itself, cobalt, how much cobalt we need, how much nickel, manganese we need, and I mean, of course, the copper, but not many people talk about the graphite. So the battery grade graphite, it's a huge demand, and I mean, it's very difficult to recycle, not like a metal. So lithium, cobalt, nickel, relatively can be recycled, but the carbon in the anode is all intercalated with the polymers and other metals. So it's very difficult. So I think one of the area is to develop producing carbon or graphite out of the carbon ore. And then also the absorbent, because I mean, instead of using chemical method, quite a lot of research effort is focused on using biochar to recover metals from the very low concentration, so that the chemical, I mean, physical nature of the carbon can be a really good candidate to produce the carbon ore base, the absorbent. So it's I mean, difficult. It's not. I don't want to say it's easy, because the absorbent itself is gotta be really clean and high purity. But we have some technology to produce those high quality absorbent. And the other thing is, I didn't mention about during the presentation, but when we build the concrete structure, what do we use? Using a rebar inside the cement and the concrete. And using thermal process, we can actually extrude the carbon fiber and sort of a forge to form a rebar. I've seen that. I mean, some folks at the Colorado use that technology to make a rebar. It's literally, it looks like a rebar, but it's not rigid. It has some flexibility, so it can have a really high resistance to earthquake and other event, but also made out of those carbon fiber, and we don't need to worry about the rust. So it can be used for, I mean, usually conventional building, sometimes rebar can get rust, and it can last over 40, 50 years, or sometimes little short, I mean, even shorter. But those rebar extruded out of the carbon or carbon material can be, I mean, last much longer, and then there's some many advantages. But I mean, is it here ready to produce all those things, but not quite there yet? But we can, I mean, spend more time and effort to produce, advance those technology to make it in an economic way. So those are an opportunity. And I have enough time, and also we didn't talk about much the ash from the power plant, bottom ash and the top ash. So it depending on the mineralogy and the location, but some of the ash material contains relatively high concentration of rare earth elements and critical materials. So that's why, like in the East Coast University and a research facility, they spend a lot of time to recover those elements, but not like in Colorado, Wyoming, Utah, even in Arizona, there's a huge the fly ash piles in northern New Mexico, close to Arizona. So there's not many studies done in this area. So there's an opportunity. And then also after the fly ash, I mean, extracting the material from fly ash, we can produce those bricks using fly ash because it has very fine particle, and then it's going to improve the physical property of those bricks. And in addition to that, I don't know about other states, but the state of California require, I forgot the exact number, 15% or 20% of fly ash need to be in a cement when they make the cement. So if the regulation change and there's another opportunity that we can use those fly ashes, like huge global cement company like Lafarge, they collaborated with the power plant company like when I was in Arizona, it's Arizona Public Service based in Phoenix, so they had a pile of fly ash, but there was a cement company needed some sort of a feedstock, so they collaborate together. First, characterize it because I mean we don't want mercury or any toxic elements in the cement. So characterize first and identify the value in there, and then we can extract and recover, and then use the remaining fly ash for the cement. So those are the I mean innovative way to use the carbon.
We do have fly ash deposits, you know, in our area. For instance, Trapper Mine from the Craig Power Station store has a large disposal site there that's been going on for decades. And we also have some up north of Bridger. There's a lot of ones there, but that'd be the kind of dirty, you probably wouldn't want to use it, but you could maybe use for rare elements.
And then it's just a think guys outside of the box. I mean, if you guys, if an audience have a better idea, I mean, use those fly ash or carbon ore. I mean, we can always discuss with the people at the university or any other research lab to find the other use.
And they use much of that in soil stabilization, like for
yeah, that's good point. I mean, I work a little bit. I'm not directly using fly ash, but use mine tailings and mix with some sort of nano composite material. So it's really, I mean, if we can make a strong material, but we don't want to characterize for just commercial usage. So use that as a food base, particularly in the mine site, because we have a whole truck and a water truck move around. So we studied a little bit of that application also. But I mean, I think a fly ash or other carbon ore material can be used to as a road base.
Any other questions? Okay, so can you guys talk about how fast can these innovative technologies, I know you talked about a lot of different things, they're probably at different technology readiness levels. Like how long can will it take for them to be scaled up and adapted so that they could potentially make a difference?
So it's me again. Yeah, I mean, technology readiness level, is it planned? I mean, pilot is 4, 5, lab study, pilot scale, 4, 5, 6, and up to 8 or 9. We can achieve probably in a 2 to 3 years. So from smaller scale in a 500 milliliter beaker size and maybe 1 ton per hour pilot plant, we can develop some technology in a few years basis. But I mean, implement to larger scale in a site level, so demonstration plant, we can achieve maybe in 5 years. But one of the hurdle is the permitting issue. So I don't think there's many new coal mine in the U.S., but there are, I mean, try to be so many metal mine in the U.S. So these days, permitting, it takes anywhere between 10 to 12, 13 years for the metal mining, starting the metal mining operation. And if we try to develop a newer technology and then implement in a larger scale, we also need to get a permit. And the current, the mine site, we need to change the permit, and it takes, so much longer than the technology advance. So that's a big hurdle. There's not much people like me, I can do, but it's more like an administration and an upper level, way above my pay grade. So, one example is I started my faculty job in Tucson in 2014. And at that time, we were asking, and when the Rosemont copper plant or Resolution Copper will start operation. And then after 9 years, and these days we're thinking, eventually, are we gonna have Rosemont mine just, 50 miles southeast of Tucson? So that's the narrative these days about the permitting. It's very difficult, and lots of people, we don't wanna, destroy the environment or anything like that, but mining industry, the general concept, it's not positive, not quite I don't want to say negative, it's not quite positive. So that's a big hurdle. So, again, the technology development and to implement in a larger scale, a lot of people out there we can achieve in a few years, but getting the permit and revise the current permit, so that's really a bottleneck.
And we have 6 years before the mines are supposed to close, so there's that window that we need to really start getting after it quicker.
There's a question in the chat.
Okay.
Okay, so Andrew Romero asks, coal resources are vast, yet today we've heard mention of black sand and paleo placers as a source of rare earth minerals, namely monazite. Arcadia Resources, based in Riverton, and AUPT Industries, who has claims around Bags, Wyoming, have monazite, titanium, and zircon critical minerals. In Utah, Energy Fuels produce uranium, vanadium, and rare earth carbonates. So here's the question. What mechanisms are available to help non-coal critical mineral resources come to market?
I guess this question for me. So yeah, monazite, it's a rare earth containing material, right? So in the Energy Fuel had a plant in Blending, Utah, southern Utah. So they mined the hard rock and they made a concentrate, but monazite also contains uranium and thorium, because Energy Fuel is the only company using the uranium mill and producing the uranium. So they can treat the uranium and thorium, and monazite, rare earth elements from the monazite is their byproduct, but they wanted to expand that capacity. So they're working on building a new mill in Utah. So the discussion that we have here. So we know there are some rare earth in the carbon ore in Wyoming, or in all those places, but relatively concentration is very low. So we have to use a conventional physical separation and advanced technology to increase the concentration. So it can be used in those Energy Fuels mill, or if possible, we can have a new processing facility in the state of Wyoming. But again, it's going to be a matter of the permitting. But if you have enough resources, you mentioned that one mine produced 13 million ton, and that's just top of my head, like 30,000 ton per day. If you can feed 30,000 ton per day into the mill, and out of 30,000 ton, 0.1% is what? 0.1% is 30 ton. Am I correct? So if you have 30 tons of concentrate, and out of that we can make, 1 ton of rare earth metals, that's huge. That's gonna, change the direction of our dependence on the China, their dominance of a rare earth elements. So we know the technology, we got the technology, and we know how to upgrade it, how to make it, but it's also an economic battle. So using really cheap labor in China, but in the US, it's maybe 3, 4, 5 times more expensive to run those plants. So that's why even the rare the concentrate that we produce in Mountain Pass in Nevada, all those concentrate we made and 100% shipped to China because we don't have a plant to economically operate and run and make the final rare earth metal. So if resources are enough and if we get enough support from federal and also community, and then I don't think it's impossible to have a plant in the US.
And, we have rail service in Colorado, so Floydell Creek and to Black Butte.
Okay.
Legitimately, we could actually move the resource to where we need to get processed to. It's not like we have to have the plant right there.
Right.
Yeah, at the mine.
But I think you've brought up a really good point in a couple different segments, is that we have technology challenges, but even if we successfully scale this up, we have, and this is not just for rare earths or critical minerals, it's bigger, that the US energy and extractive sector has to compete with state-owned companies, with entities that don't have to follow the same labor and environmental standards, don't have multi-year or decade permitting timelines. So that's like a big part of this, I think, and definitely a reason that you have to involve like policy discussions in all of this, but it's completely in our own national interests, in our economic development interests. The fact that we have the TerraPower project in Wyoming coming to Kemmerer, that project has already been delayed by 2 years because they were going to buy Russian fuel and now they're not. And in Wyoming is the largest, we have massive uranium reserves. The United States doesn't have the enrichment facilities. So there's certainly very complex, but like the technology side is only one piece of the puzzle.
Yeah.
So I don't know if I solved that, if anyone has any ideas, but truly, like, we have to acknowledge that, just like I was talking about with Corona, if you value safe and good working conditions and environmental practices, then you have to value those, and somehow, the Western world has to figure out how to do that.
So it has to be the collaboration with federal government and the university and research institute like Los Alamos and Oak Ridge and all those, but also that has to be with the private sector, private chemical company, global chemical companies such as the BASF or Solvay, because they know how to make those chemicals, but they make a lot of money for making extraction for copper, because we produce 20 million tons every year. But how much is total rare earths that we produce per year? Maybe 20,000 tons? I don't know. It's really, really small. So those companies are not interested in invest their money to develop the new reagent for rare earth, because it doesn't make sense for them. So federal support or collaborative effort got to be happen together.
Do you have a question?
Do you have benefits of what you do with Wyoming?
Are you talking about
Yeah.
School of Energy Resources? Well,
Compliance or spokesperson?
the closest that I know is Brian Wilson at CSU. So he's really incredible. He's, founded, and I'm sure he wouldn't take this kind of credit, so you just let me give it to him. But he's really founded the Energy Institute at CSU. It's very large, multidisciplinary effort. I would say, the School of Energy Resources was set up specifically to serve the state of Wyoming. That group wasn't, although I think he and others there would certainly be interested in serving Colorado. So I don't think there's anything exactly like the School of Energy Resource, really anywhere in the US, but that would be where I would start. And I think he's so knowledgeable about all the energy work going on in Wyoming, and he's a good collaborator to us also. So that's where I would start.
About CSM.
So
I'm a newbie at the CSM, but we have an energy system engineering, and then we also had a vice president of technology development of something. So we had some group of people working on energy system in that field, and so I'm pretty sure there's something in the CSM too.
Well, the CSU is the land grant university.
Right, yes,
in Colorado.
yeah.
So Robin, did you have any other?
School of Mines also has a C.
Yeah.
We worked in collaboration with previously. One paper we actually put out was rare extraction from fly ash. Suggesting that viable resource station. So
Yeah, for this space and for that comment I made on that, they're really great. Payne Institute. P-A-Y-N-E.
I know. I'm actually gonna pose a question and some thoughts. So it seems like we're facing a capability gap or a time gap between when mines, there's going to be a desire to shut down mines because they're no longer economical from a traditional coal standpoint, and the necessary market for these new, coal or critical mineral technologies. So I guess this is for all of you, what's our kind of lifetime of mines, buildup of technology, and then I guess for Holly, kind of the broader thinking in the university paradigm is, where do research parks, research campuses come into play that bring universities and corporations together? Because you see all these research parks, these research communities, and every university I've ever been at, and I'm a former university person, they're empty. They're largely empty and really quiet. So how do we engage things like Colorado State, CU Boulder, School of Mines, that have these larger engineering programs, chemical sciences, into this to accelerate that transition and fill that gap? That's to anybody in the audience too.
Right, that was like more than one question.
Kind of.
We need an administration that's willing to help us.
Yeah.
We don't have that.
Well, I think it's
Why don't we
really,
get a little
yeah,
better-
that's,
The governor's better than ours. I mean, we've cut out our energy sector here since. I mean, how can you cut off your hand and split it? You can't do any of this technology improvements without, speeding up the permitting process and all 9 yards.
well, and even R&D funding.
Get a changed administration.
Yeah. A lot of traditional programs at the Department of Energy that could sponsor the kind of work that we're doing on the coal, the carbon engineering coal to product side are not funded currently, that have been historically funded. Same with the nation's oil and gas program. So there has certainly, and that's why, we've been able to continue our work, is that we do have the support from the state. So, I mean, at the end of the day, like I said, we can only work on what we have money to work on. And so that makes a really big difference for us. I think anyone in any administration does understand the need for these rare earths and critical minerals and domestic production, and uranium, which I guess is no longer a critical mineral. That was very political, but so it's more a question of how you do it. So I think it's a good point on your question about, so it was essentially like innovation centers are largely empty. Ours are not empty. But so I have to, and also the Energy Institute, CSU, is definitely not empty. They're kind of thriving too. So where are you talking about? Because that's not been our experience.
I'm thinking like Purdue in Indiana.
You should focus on energy states.
Yeah, but Penn State.
Yeah. Oh, that's surprising. So.
But this was also a decade ago.
Yeah, I mean, it does, it simply takes funding to scale these opportunities and I will say it's really important to find anchor tenants when you're gonna stand up a facility. And understand kind of the thing about the integrated test center is that its trajectory has kind of followed the large scale pilot carbon capture program at the Department of Energy. So as technologies like this membrane one I talked about advanced from bench scale to pilot scale, this center was being stood up at the same time. So you have to be very focused on and it's really hard when the pendulum starts swinging in terms of research funding to plan for that. So, but luckily, so far, carbon capture's remained on the table at the federal funding level. You guys have?
All I know quickly that the original scope projects are a possibility for some of that funding to be injected into situation. Whether that's CFP or school money. That provides multiple work on these problems at the same time, which is the future of sort of it is hard to get everyone engaged. And I was gonna add to that the private sector. You don't see universities leading extraction facilities. It's gonna have private mines. And some models kind of buy into it later, but if the state's not putting for
So that's a good point. I mean, hopefully there will be a phase 2 of the core CMs, and we would definitely want to see for Dalton. Wes, he spent his holidays writing the proposal, but you know, we're still interested in collaboration, and there is money for this kind of work in those programs.
About to be
It's about to be.
Maybe already. Contained in your question earlier, there's like an inflection point here. Lines are going to shut down. There's some technology coming on board that could ameliorate that a little bit if it happens fast enough. But how much of the actual mining is is that a significant? Could that reach a significant margin of the current demand?
It can't, I mean, for us, it's really hard in Wyoming because we have the biggest mines in the world. So if you think about our entire portfolio, I mean, Trina's led some work and has faculty working on things that could actually, but if that's at the earlier stages, the things that are more advanced, we would hope to get to 10 million tons a year. So like a medium-sized mine in Wyoming could be 50 million tons a year. But that's, I mean, that's why we work on carbon capture and storage, other things as well, hydrogen from coal. But it's meaningful to that mine. So it's important to put in context that no one thing is going to be able to save a mine or a community. So we have to look at a lot of different things. But I think part of our issue in Wyoming is that we're focused on revenue. If you start to look at what they're talking about in terms of taking rare earths out of coal, you can't maybe save all the mines, but you can create a lot of jobs based on similar skill sets. Start to think about like the extraction from the material, and it doesn't save all the mines, but it hopefully help the community. So the answer is it depends where you're looking at, right? For us in Wyoming, we have to look at like big coal up as much as we can. But it might be a little bit different in other places. I don't know if Dominer's going to get a perspective.
I think you touched on it. It has to be a diversity.
Yeah.
Never technology, but you're still gonna need energy.
For sure.
To create the electricity.
Good point. And it has to be reliable.
Wind and solar. We're gonna need a lot of coal just energy. If we're gonna be self-sufficient.
Right. And we actually have a series coming out that's totally unrelated to what we're talking about here on electric reliability and how that's starting to change in America. in ways that we haven't seen since in the last 60 or 70 years. So happy to engage on that as well.
There's solar. What's that all? Well, I'm just saying.
So
We gotta have an administration that's willing to tell us the truth, one, plus work with us on doing some of the stuff.
We say 2030 is that finish all mining type thing. That might not be the case, really. I mean, when you think about 20 Mile or 40 Owl Creek mine, I mean, they're a rail, they could send it overseas, they could send it to other states, I mean, it's not, you can't burn it here anymore, but at Hayden Power Station, but that can happen. Colorado, they're on the rail, they can legitimately, send that coal out as well. And that all that coal can be shipped to a lab, not a lab, but a processing plant for things too. So there's this 30 might not be exactly what we're there, maybe.
I agree with you, but I mean, that's the overall department initiative to lower it. If you're shipping it to Germany to burn, what the hell have you done? Take it away from here. I mean, you guys are all.
Okay, so I guess I want to close with saying, when you think about like innovation, or do you guys have anything else you want to add?
One technology real
Go
quick,
for it.
I'll call it a day. Yeah, I've worked in underground coal gasification quite some at length. And I was in charge of identifying the best potential area for UCG in North America. And what I found is the Green River Basin probably has the best potential on the geologic criteria that I've used for underground coal gasification. They got thick seams, steep. It's not a freshwater basin like the PRB is, and might be something that might be of value decades down the road. I know it's kind of come and goes, that type of technology, but we did have at Link Energy actually had a test burn that was up there near Wright, Wyoming, that they had it permitted through the state, but because of falling natural gas prices, the syngas just didn't economically make sense anymore. So anyway, that's another little technology. I know it's not related to mining, but it's something that could be way out there. And some of the best areas I think are just west, east of Bridger and around Rock Springs Uplift and toward the Trona Patch. There's a thick coal that's deep and has potential geologic criteria. Commercially, that's another thing. One of the things that is generated during the UCG process is CO2, which isn't a pleasant thing to deal with. But our thoughts at that time was that we would add it to the pipeline, Chevron say, and use it for enhanced oil recovery from the old oil fields in Wyoming, where we can sequester the CO2 at the plant itself. But anyway, something
Lots of stuff out there
Yeah.
that extends even beyond this program. So lots of opportunity. Jehan, what do you think?
No, I think.
Last
you
word.
covered most of it. So,
Covered a lot of ground. So
Yeah.
thank you guys both for being here. Thanks for the discussion. The one thing I would just say is when it comes to research and innovation, especially when you're at the earlier stages of development, like 90% you can expect to fail. So, it's really important to just come up with ideas. They may or may not work, but they're cheap to try out at the small scale, and it's really worth throwing some spaghetti at the wall when it comes to innovation. There's no dumb ideas at the beginning. You can weed those out fast, be ready for failure. So I think that's something you probably feel from a lot of people in the innovation sector, that we're optimistic because you have to be, because almost everything you work on doesn't work out, but in the end, the ones that do can be transformational for in so many ways. So that's what we're working towards, and just really appreciate again the partnership and the college hosting us here today. So thanks so much.
The second session is school communities and the energy transition. I've been told we're going to call it the energy transformation. So we can insert either or here. And how this conversation goes. We have Selena Gervais, a research scientist. She presented with the recorded session earlier today. She drove with Laramie to be here in person for this afternoon session, so we appreciate that. She may be, I feel like, the only community benefits expert on beauty projects in the country. I know there's others, but as the funding rounds come around, I think everybody calls us to use Selena to help with those. So she is the chair of the session. We have Tiffany Dickinson, director of the AD&C. Obviously has her pulse on the community and has done a tremendous amount of work assisting us in Corsium over the past couple of years. We have Ray, that former county commissioner. I feel like the engine behind the JOLT committee, and probably has a couple other titles in there. But again, it's been instrumental to this project and helping us make connections. We learned a lot at the JOLT conference this past year. That was posted here, correct? So I'll let Selena get started. Thank you.
Okay, wonderful. Thank you all. I'm excited that I made it here today. I was teaching this morning, so I had to pre-record my presentation, but I'm very glad to be a part of this conversation here this afternoon, and glad to see so many people here. Really excited to be here talking with Tiffany and Ray, who are really experts working in these communities. You've heard a little bit about the work that we're doing at School of Energy Resources related to communities and community benefits plans and environmental justice. But this is really an opportunity to highlight the work going on in the communities and with agency and JOLT, and also to talk all the expertise that everyone here is bringing. I know we have a lot of experts on how this transformation or energy expansion, I've also heard it called, is impacting our communities. And I think these are really important conversations to be having right now. So I'm going to start just by asking each Tiffany and Ray to give a little bit broader of an introduction to themselves and talk a little bit about the work that AGNC and JOLT are doing. Tiffany, could we start with you?
Certainly. So I'm Tiffany Dickinson. I'm the Executive Director for Associated Governments of Northwest Colorado, or AGNC, as you often hear us referred as. We are the Council of Governments for 4 counties in the northwest corner of Colorado. That's Mesa, Moffett, Rio Blanco, and Garfield County. We are also the Economic Development District for those 4 counties plus Routt County. And we also serve as the Enterprise Zone Administrator for 8 counties, not including Mesa, but we go all the way over to Clear Creek and Gilpin County. So we work a lot in economic development, a lot in policy and advocacy for our communities. We do have lobbyists that are at the Capitol even right at the moment. So yeah, and we're here looking out for our communities and trying to figure this out alongside them.
Thank you, Tiffany. Ray.
Yeah, well, thank you, ma'am. Yeah, Ray Beck, former Moffett County Commissioner and Mayor and City Council, and then on a bunch of boards and commissions, also served with AGNC and chaired that for a couple of years as well. But I am retired after 14 years of public service. I also served on the Office of Just Transition with my good friend Dennis Doherty back there in the back, who come and fill in the gap for Wade this morning, Wade Buchanan, who is the Executive Director. Dennis is the chair. I, at the time, was the vice chair and was instrumental in helping write the action plan that was distributed to the governor on December 31st of 2020. And so that's a 20-page document if you ever care to look it up and find out what House Bill 1314 actually produced, so, or was required to reproduce. But anyways, with that being said, I am currently the chair, I guess you would say, of JOLT, which is an ad hoc committee. That ad hoc committee is made up of different representatives from across the state of Colorado. So Lisa Jones, president of CNCC, is on the committee. I have a Commissioner Sue Hansen down in Montrose, and then Commissioner Wendell Kuntz out of Delta. I also have Rose Puglisi, who is actually, Rose and I are the one that actually started this committee. And then we brought in these other folks. And then, so Rose is currently the representative for House District 14 over in Colorado Springs area. And then I have Matt Schuler, who is the editor of the Jackson Star over in Jackson County over in Walden. So with that being said, we're just a group of 6 people wanting to make a difference. Our committee actually stands for Joint Organizations Lead Transition. And our mission statement is very simple: to advocate, communicate, and educate. And by doing so, we're a group that wants to support all the above approach to energy. We're not picking winners and losers. And by doing these conferences, it's just a matter of planting seeds of opportunity. And it's never, ever been about filling the room with bodies. It's about filling the room with the right people. And that's why we have an invitation list that we put out, because we hope that through industry, through businesses, through our local elected leaders, and through our state representatives, that somebody will, maybe that conversation will spark an idea and say, yeah, we can do this or we can't do that. So that's part of our, that's what our group does. Our next energy summit, well, we had our first energy summit here in Craig, Colorado, June 2nd and 3rd here at the Quality Inn. Well attended, got a lot of good feedback from it. Our next one is going to be scheduled in Montrose. It'll be on June 27th and 28th. So if you're down in the area or you care about the all above approach to energy, whether it be hydrogen, whether it be nuclear, whether it be geothermal or any other of those resources, because we feel at the end of the day, with the push from the state of Colorado and our federal government to go electric this and electric that, we're going to need all those resources to meet our energy demand. So if you're there and you'd like to attend, that's June 27th, 28th in Montrose. So I'll stop there and see what else you want to talk about.
Thank you. So I'll get us started just by Brett prompting with a few questions. I would love for this to be a conversation, so feel free to jump in with follow-up questions or comments. But Tiffany and Ray and I had the pleasure of having a couple of conversations over the last couple of weeks as we got ready for this panel, and talking about, what you're seeing as being what happens to local communities when mining and power stations close down. And just wondering if you would just jump the conversation off with kind of talking about what you see as really being those big pivot points that are happening.
Go for it.
No, go for it.
Go for it, you said?
Yeah.
Well, I think we can probably all agree that, when change happens, that's an opportunity for other things that we can take a look at. So we talk about diversifying our economy. That sounds pretty simple, but diversification takes a lot of time. It doesn't happen overnight. It's like any technology. Technology doesn't happen overnight either. It takes a lot of time to get your technology perfected. But I can tell you that Moffat County is not sitting around and waiting for the government to come in and bail us out. We're doing everything that we can humanly possible to diversify the economy. A couple of examples would be, I gotta get my list out, brought my notes. So the county is actually pursuing a pumped hydro project. It's a $1.5 billion project, which is capable of producing 600 megawatts, about half the size of the tri-state power plant. It'll include 2 reservoirs, 4,800 acre feet apiece, and it'll bring in about close to 300 jobs while they're building it. I think this is supposed to take place in 2026. And at the end of the day, when it's all built and everything, that'll give us about 30 permanent jobs. So when you talk about the definition of economic development, my definition, and maybe others, it's one job at a time. So every time we create a job, that helps our economy locally. And after you make $1 and you spread it around 7 different times. Another thing we're doing is repurposing the Trapper mine. And this is with the permission of Michael Morris. He's the CEO out there and his board. We came together, the community came together with Colorado Space Business Roundtable this summer. And we came up with this brochure to encourage and promote the Trapper mine facilities out there. And I'll just read a couple captions, and I got enough brochures that if anybody wants one, willing to, and you can take it with you. But basically, this is a ready, set, go for industry. Trapper Industrial Park is a rare, fully independent location on 11,200 acre site with over 85,000 square feet of modern administrative and industrial work space. Location is sound abated from business, municipal, and residential areas with dedicated utilities, explosion permitting, and uncontrolled airspace. So rather than spend $1 million to tear down $1 million buildings, would make more sense to find somebody that would be willing to come in and turn that into some kind of manufacturing place and save those buildings, and then at the same time help our economy. And so with that being said, I think it has a lot of potential. Again, I'm not going to go into a lot more detail there, but if you're interested, that's one of the things that we're doing in this community, trying to promote those resources. Another thing that is going on, the county wants to do a feasibility study on our rodeo grounds here. So the college president and her staff moved their rodeo program up from Rangeley to here. I think that's brought a lot of folks from outside the community, especially our ag community. And that's one of the things that drives Moffat County is energy, agriculture, recreation, and small businesses. And so with that being said, they got a study going out where maybe we can enhance, grow, build out, make a better fairground out of that by building out an event center. So it's very exciting. Another thing that's going on with the city of Craig is a housing project, a $10.5 million project, sits on the old hospital location, which will produce about 20 units. It's for the workforce housing project. And again, it's housing is a big deal. I mean, no matter where you go, people will talk about, we don't have enough housing here, we don't have enough housing there. So I have to applaud the city for doing this. I think this is going to be a great asset to our community. And then the city of Craig is working on a water park to take advantage of the Yampa River that flows through Moffat County. And so that's kind of been a joint project with the city and the county to do that. So I think there's some opportunity there. And then power lines. We have two power lines that are coming through Northwest Moffat County. We got Transwest and we got Gateway South. This has been 18 to 20 years getting to this point where they could actually put a shovel in the ground, which they just did last fall. So they're building, pouring the concrete for these structures. At the end of the day, that produces some economic resources for sales tax and stuff like that. But at the end of the day, once they get these power lines built coming out of Wyoming, going down to Las Vegas for their renewables, that will give us some property tax and business personal property tax. But it has to be in operation for a year. So once it's energized, then a year after that, we'll start receiving some revenue from that. So I think that's going to help our local economy as well. And then another thing that the city's doing, of course, they're working on their parks. They just almost completed the Woodbury Park. We have a very, very robust Parks and Rec group here through the city in Moffat County. And if you get an opportunity before you leave, drive around, take a look at them. But they almost done with that. And then down there last night where we had the reception, the Alice Pleasant Park, they're going to put that on their schedule to redo that next year and enhance that park. So those are, and you say, well, how is that going to bring people to Craig? Aesthetics is very important to any community. So if you drive through a community and it looks nice, you might just take the opportunity to stop in Moffat County, Craig, Colorado, spend the night and spend some dollars and help our sales tax. And so that's, and then one of the other things I got to talk about is the new courthouse. This has been a big deal. One of my last official actions as a county commissioner was to sign off on the purchase of the old Kmart building, roughly 95,000 square feet. We were able to purchase that property, 11 acres for $2.3 million. Never spent a dime of taxpayers' money. We didn't have the taxpayers to ask for a mill levy or any kind of sales tax. So at the end of the day, we just dedicated that building. The commissioners did this summer, and we were able to move all the county operations over to that new courthouse. It's on one level. There's no elevator agreement. You walk in, public side's on one side, the courts and the social services on the other side, which is the security side. And the only thing that's not in there is our sheriff's department and our road and bridge. We were able to take 3 of our buildings that we currently had and put them on the market, get them back on the tax roll. So I think that's another thing that has been a big deal. And then the city of Craig, and it's been a regional project. If you drive out east of town where the Yampa Valley Electric Building is, there's a 4 megawatt solar array panel out there that I think is about ready to go online. So that's going to be a big help. And again, it was regional. And I think one of the only ways that any community, coal impacted community, is going to survive is by working regionally. You can't just do these things in a silo. You need the help and you need partners. And so we talked about that earlier about developing partners and communicating and stuff like that. And so with that being said, I'm going to leave it off there and turn it over to Tiffany.
All right.
Okay.
Well, AG&C has been working on quite a bit. We recognized that the coal transition was going to happen long before it was ever announced. And so we began looking into what could we do. The first thing that we wanted to know is what are the impacts of this going to look like for our region, for these counties. We do have Moffett, Rio Blanco, and Routt County for a total of 3 mines and 2 power plants that are closing. So it's pretty terrifying for us. In Moffett County, you're set to lose 46% of your GDP with your mine and power plant. And then in Rio Blanco, they're set at 26% just on the coal. Then you add in oil and gas. Rio Blanco is huge in oil and gas. That totals 71% of their GDP. I don't really know how they survive this other than collaboration, regional projects. And that's where AG&C comes in. We work at a regional level, and so we're able to assist with different projects. We're also actually a government organization as well, and so we can apply for grants on behalf of our members. We so far have been investigating alternative energy sources. We've been working with the state of Colorado, with the legislature. They passed HB 23-1247 last session. That is going to be the advanced energy replacement study that the state is doing. Excuse me. Let's see, we worked on the Trapper Industrial Park brochure, and we're, just constantly working with our communities. I think that Northwest Colorado actually has it a little bit harder than maybe the rest of the state, maybe anywhere else going through coal transitions. We have a lot of other regulations that are coming. We have a lot of other introductions that are coming, and we don't know what the impacts of those are going to be. So I don't know if everybody's aware, if you're not from Colorado, but we are getting wolves next month actually, and that's pretty terrifying when we have such large ag communities, and so we have the largest elk herd in the world in Moffett County here, and the amount that CPW ends up getting in the hunting licenses from the out-of-state hunting licenses actually covers the wildlife portion of CPW. It's huge. And if the wolves come and decimate that pack, what's going to happen to the state of Colorado? There are just so many things going on right now. We've got the AQCC, that's the Air Quality Control Commission. They are coming out with regulation after regulation after regulation. And now they're coming after manufacturing, which manufacturing and industrial park, that was a huge drive for us, is how do we attract new manufacturers, new primary businesses to our region. And at this point, it's getting kind of scary. How are we going to be able to, when there are regulations on GHGs? When we talk about we've got till 2030, we don't have until 2030. I know those are the announced dates, but AQCC just put out a reporting mechanism on the power plants and the coal mines, and that will be followed up with fines and fees, and it's a push to shut down the coal even sooner. So I would expect 2028 probably. We really are under attack, by the state of Colorado, and I'm not sure that they realize it. But we need to push back, and we have to do that by working together.
Yeah, I think that transitions really nicely into the next question that I have here about current regulations and policy decisions, both state and federal, and how those are affecting communities undergoing the transition. I think you're starting to talk about that now, and I know that was coming up a little bit in the last discussion as well. Can each of you comment a little bit more on that?
Sure. I mean, it starts at a federal level, but then we end up at the state level where, we do not have a friendly administration at the state. A lot of people consider our governor be a 5-county governor, and it was really the Front Range that actually decided for the Western Slope that we were going to get wolves introduced over here. So it's been very unfair to us. As far as all of those policies go, we don't feel as though they're looking at what comes next, right? So you close the coal and you're making a lot of laws, California, and we're following in the push for EVs. You're going to plug them into a grid that doesn't have any electricity. California decided to do that, and the following day they had to say, but you can't plug in your cars between the hours of, or only plug them in between 11 p.m. and 5 a.m. because that's when the grid's available. We have to work together, and we've got to get our administration, both the federal and the state administrations, to realize that there's more to the story, and just shutting things down, as former Senator Rankin would always say, they gave us a date, not a plan. We need a plan to get through this.
So, Tiffany just mentioned working together. I think that's key to our survival. As an example, we have House Bill 1247, which is a study bill. I think it's due in 2026 of July. So you got that based on the fact that we had our local representatives put that bill together, Dylan Roberts and Megan Lukens. I'll give them the credit for putting that together and also including nuclear in that study. So you have 1247, you got our state representatives, you also have Club 20, you have AGNC, and you have the local community coming together, working together. And I think, we talked about change. We talked about when change happens, we have opportunities. And I think this is actually, when you think about it, it has pulled us together. And so it's not about doom and gloom. I mean, we're very optimistic, but we have to be real too. And when I say reality, as an example, our 10 top taxpayers here in Moffat County are all energy based, right? And of those 10 top taxpayers, that equals 60% of our assessed value, or 57% of the budget. When the two coal mines shut down and the power plant shuts down, that's 46 to 47% of our budget currently. And those numbers were given to me by our assessor back in February of 2022. I can't imagine any of those numbers changing that much as of today. So with that being said, Moffat County is the second largest county in the state of Colorado in landmass. We're 60% federal, 40% private. And what does that mean for us? That, we have a lot of opportunities here in Moffat County. We actually came together several years ago. And I'll tell you, one of the toughest things there is for any community is to come together on anything. And I think we can all equate to that. But one thing that we did do here, we have a tagline now. It's called Colorado's Great Northwest. And before we've also got the elk hunting capital of the world tagline, but the Colorado Northwest thing, everybody's incorporated it. The college has it, counties, the city, the hospital, the school district, they all have the same logo. And I think we're trying to all send the same message. And I think that's really significant because at the end of the day, you want people that are like-minded. You don't want people split and go in different directions. So I think that's a huge thing for us. But when it comes down to policy, and I've said this before, it would be nice when our state legislators put out bills, if they'd actually talk to the people that it's going to impact, rather than just go ahead and move forward with whatever their agenda is. And then at the end of the day, we're the ones that are gonna reap the lack of benefits or the benefits of their laws and their rules and their legislation. I'll give you an example of that. If you know Rose Puglisi, who is a former Mesa County Commissioner, she put it very well in her notes, if I can find it here. Oh yeah, here she is. So this has to do with Proposition HH. I'm not telling you how to vote, so you don't have to worry about that. That's your choice. But this is what she said when she debated with the governor here just within the last couple of weeks. She said, Puglisi said the solution is to bring local governments to the table, including their school districts. And she also said here that, and when I talk to people on the street and people door to door, they don't think it's a significant property tax savings at all. And remember, it's just a decrease or an increase. Your property taxes are still going to go up. But here's what I really wanted to share with you. She disputed Polis's contention that the measure would provide significant savings. She also complained that local officials, who are actually the ones that spend the property taxes, spend the dollars, like your county commissioners and your city council, that they weren't consulted by the state house when they wrote the referendum. So it'd be nice, again, if when these policies, let me back up. When you're elected to the state, or when you're elected at the local level to represent your community, and even though you might be represented and elected by a district, whether it be the House district or the Senate district, you're there and you're voting on behalf of the state of Colorado, not on the behalf of one county versus another county. And I don't know if those people understand it. So when they come together, they come together and they have their own agenda. But those, when they do that, whatever rules and laws they pass affects all of us. And so it's not a one size fits all, and it never should be. So with that being said, I hope that addresses your question when it comes to how this policy should be driven going forward.
Yeah, definitely. Thank you both so much. I've heard you both talk about the importance of partnerships and working together and collaboration. And that's something that is very near and dear to us. Also at the School of Energy Resources, we really believe strongly that developing these new industries require a lot of community engagement and partnering with communities in a way that empowers them to be decision makers. I'm just wondering if you could speak to a little bit of, in your experience and what you're seeing in communities right now, what's working in terms of building collaborations and what's not working? What are the challenges still to building the right collaborations?
Oh, why don't you?
Oh, shucks. Okay, so I think we've got several examples, and I already kind of mentioned some of them, but you know, with the solar array thing, you know, whether it be the city of Craig or whether it be Joel, you know, supporting all the above, and that includes coal, that includes nuclear, and that includes other resources, but coming together regionally, I think is really important on how we interact and how we get through this energy transition. So I think that's important, but not just regionally, I think it's also developing and enhancing and enhancing those relationships that you have with your state leaders. I think that's important. Also reaching out to your local elected officials. I think that's important because oftentimes they have access to your state leaders that the normal average person wouldn't. And so I think those are great resources and we should use them more and more often. And then the industry in itself, I think that's another opportunity for us to work with them. But it's about working together, coming together, and communication. I think that was mentioned in one of the presentations earlier today. And our college is a big part of this too. I gotta say that the college is there to help support this transition, whether, you know, in educating workers that don't want to move on and are still young enough to, you know, not quite at the retirement age. So the college is providing some of those resources and we're fortunate to have it. I mean, this is a big deal for our community to have, whether it be in Rangeley or wherever, but through the Office of Just Transition, there's 11 or 12 counties in the state of Colorado that are going to be directly affected by the shutdown of coal. That's directly affected. That does not include the indirect effect of how that's going to look for communities. And so you got to include the railroad as an example, because we can rely on that to haul the coal out. But those are just some examples I think that are important.
Thank you.
So I feel as feel like it's kind of cheating for me to answer this question. AGNC, at a regional level, we have to collaborate, period. I can't work in a community that I don't live in if I'm not working with them. So for us, we have collaborations with CNCC and with CHAPA and, with JOLT, and we're working across state lines. We just recently submitted a recompute application through EDA, excuse me. And we actually are pulling in Southeast Utah on that as well. They're going through a lot of similar issues that we are. We very much believe that a rising tide floats all boats. And so that is really all that we do. And quite honestly, it's really easy for AGNC to collaborate because I never come and ask you for anything. I come and offer my assistance. Sometimes that's, sometimes that can be through funding. We don't have a lot of money, but we have a little bit, and we're happy to help our members out. Mostly it's with technical assistance. Capacity is a huge issue in these tiny communities. And so we'll help them out with writing the grants. We've offered to help with managing the grants if we need to. Basically, whatever a community needs, let me know and I'll figure out how I can help you. I don't need you to, tell me what you need. Just, what's your issue, and let's see how we can help. And a lot of times that's just connecting you to the right person, even, which we have contacts across the country. As the Economic Development District, we're working with EDA directly. We're working with DOE directly. We're working with USDA. So all of these federal organizations or entities that we can connect with our local communities, and working within those local communities. Because again, I live in Grand Junction. I'm not coming to Craig to say, no, how about you tell me what you want? So.
I will say AGNC has been a great partner for Northwest Colorado. In fact, they support our JOLT committee, our mission statement, and what we stand for. And that sends a huge message. But at the end of the day, when I think about my career serving our community in an elected capacity, it's about relationship building. When we started this JOLT committee, when we started this Northwest Colorado Energy Summit, you could get on the phone and you can call and say, yeah, I remember who you are. And I think that's so important. People need to understand that building relationships, no different than marriage, is so important. And even probably more important now than it ever has been. And if we're going to get anywhere and change the narrative for Colorado, then it's going to be all of us working together. It's not going to be any one organization's or any one person's responsibility. It's going to be all of us working together. Relationships are important.
So given that, how important relationships are and how important communication is, how can coal communities have meaningful conversations on transition decisions with state and federal policymakers?
Well, we're trying to figure that one out.
Just a little question for you.
Up here in Northwest Colorado, we do have two really great state representatives. And it's kind of surprising because it is more of a conservative county up here in Moffett, but we have a Democrat senator and representative who have reached across the aisle to work with our conservative local electeds. On the HB 1247, we worked very hard on that one. We actually have the word nuclear in there, and even with the supermajority over at the Capitol, we were able to get it passed with the word nuclear in there. And that's actually a huge deal because over at the Capitol, it's a scary word for them. So, I think reaching out to your advocacy organizations, if you're not already working with them, that's a great start. We are always working with all of the state agencies, and it's, just constantly discussing what these issues are and what solutions can we work on together. And so again, it's just all about collaboration.
You know, when we talk about regulations and policy decisions and things like that, I have to say that I think one of the biggest hurdles that any community faces is the regulatory hurdles that we have to go through to get from point A to point B. We'll use the power line as an example. 18 years to come together on the landowners agreements and the permitting process. In most cases, companies of that size or any size would probably throw up their hands and say, you know what, forget it. It's too much work and it's going to cost us way too much money. So I think if there was a change to be made at the federal and state level, when it comes to rules and policies and permitting process, is how can we change those regulatory guidelines so that can make it easier for communities to diversify their economy and get to the point where they can actually thrive and survive. And I think the same thing goes along with, you know, there's a lot of opportunities out there for grants, and that's great to have a grant. But at the end of the day, when you have all this red tape, you got 20 pages of a grant to go through and you got all the follow-up to go through, it's like, what's the point? You know, it has to be in such a way where it's humanly manageable. And I'll use the city of Crave as an example, or even the college. You know, when you got to write a grant and there's all this requirements afterwards. I'll give you an example for the JOLT committee. We got county commissioners throughout Northwest Colorado that you ask them for XY, I mean, whether it be tri-state or XL or commissioners, they don't grill you. They don't ask you to fill out a form. They just believe that what you're doing, they know who you are, you know what you represent, they believe in our mission, and they'll give you the money. But we don't have to follow up and give a 15-page report on how we spent that money. You know, we're a nonprofit, and we're just trying to make a difference in the state of Colorado. And so that's what they do, but they don't give us a 20-page application to fill out and then be accountable for 2 years afterwards. And I think those are some of the changes that need to be happening.
So, given all those challenges with capacity, I've heard you both talk about this issue of like capacity to access resources and to bring resources into the community. I've also heard you talk a lot about what all the positive things that are going on and all the projects that you're working on to help facilitate this transformation that we're seeing. Are there other potential alternative pathways that are going to help carry our communities forward through this time period, this transformation?
Well, I think you guys having this forum, I mean, the University of Wyoming is willing to reach out outside their borders, outside the state of Wyoming, reach over into Colorado and Utah and other states to have these kind of conversations. You know, rare earth minerals is a very important topic to be discussed, and how that looks going forward, because we can't shut mining down totally. I mean, you think about the steel mill example. If we shut down coal completely, which is what their intention is, and coal can get to an extreme, and I don't know what that degree is to bend metal or to make metal, but you know, is renewables going to do that? Can they get that hot and create that kind of heat where we can actually make steel beams and create and build buildings and stuff like that, and steel for everything else that we need? Power lines as an example. So those are the kinds of questions we need to be asking ourselves. But I think having you guys here and having this forum in Moffat County in Colorado, I think that's a step in the right direction.
Good. What about you, Tiffany?
You know, I think this is an opportunity for the communities to remake themselves into what they want to look like. You know, one of the options that I think is a really great option here and across the country is nuclear. It meets a lot of the environmental regulations and concerns. You know, it's firm and it's stable and it's available, and you know, and to go along with nuclear, right, you have to have the fuel, which is currently only available out of Russia. So with the small modular reactors, they use something called HALEU, which stands for high assay low enriched uranium. And yeah, I mean, we just need to get some uranium. We need to get a processing plant, and we need to start processing HALEU here in America. There's funding available for it. And, you know, I think that a lot of the country, does the NIMBYism thing, and not my backyard. Well, I think that Northwest Colorado, Wyoming, Utah, we're pioneers, right? We're not scared of these things. We'll figure it out. So let's figure it out and do it. Got to figure out how to get the policymakers to allow us to, but I think it's a great opportunity. And the opportunities are everywhere. We just have to be thinking outside the box, and we have to look for, what's available. What do we think we can do? But I'll tell you, these are the smartest people that you will ever meet, are these pioneers. And I mean, don't underestimate them to do anything.
Okay, well, thank you both. As we wrap up, are there any comments, questions from the audience, from all of you? Yes.
Do you feel like you gained any traction or made an impact with the majority of the state of Colorado with your lobbying? I know that you talked about one House bill, or do you feel like it's mostly backsliding?
As far as the nuclear goes, I think that we're gaining a little bit of traction. It does seem like people are becoming more open to it. Those before that were very much no, they're starting to say, okay, let's get more educated. AGNC, one of the things that we did in partnership with Colorado Mesa University was we screened this film, Oliver Stone's documentary called Nuclear Now. And we screened it in 5 communities, and in each of the communities, the biggest request afterwards was just more education, which is what we are trying to currently find funding to engage in, because Department of Energy, they really believe in this community engagement, get it done before you do feasibility. Well, feasibility commences in July, so we need to get this community engagement piece done now. But yeah, I think that as far as the nuclear goes, yes, we're gaining traction. As far as all of these regulations go, we are continuing to receive more and more regulations. Although I will say that the other day we actually had DNR reach out to AGNC because they want to have a conversation with our communities about a bill that they're going to run next legislative session. And that was new and refreshing.
Thank you.
And I think that the headways that we've made, elections matter. And so when we get the right people in there fighting for their constituents and our quality way of life, and I can say that, we got some legislators on the West Slope that are really trying to do their best and also build those relationships with the other side of the Continental Divide. And I think that's going to be huge for us going forward, because we know we're going to have legislation. It's one of those deals where, we put 1 step, 2 steps forward, and then we have to take 3 steps back because we've got another rule, another regulation. We got air quality thing we got going on. We got our ag community being attacked because of this pollution or that pollution. And I mean, there's just so many things coming at you, and it's hard to get ahead of it, if you will. But I think having our elected officials at the state level are key, and we need to continue to rely on them, and I'm glad they're there.
Question on your social justice, you talked about in the video this morning.
Yes.
A lot of us feel like we've been put at disadvantage over other counties, over states. How does that apply to this type of thing? That was part of the DOE's social justice.
Yeah, absolutely. Yeah, so.
They ever addressed that? Apparently not.
Yeah, so, in those DOE grant applications, part of it is through the community benefits plan, having a plan for environmental justice through this Justice 40 initiative that I talked about a little bit. And so that is kind of, taking account of, where the specific risks or needs, concerns of communities that might bear specific burdens versus, what communities do the benefits go towards. So, as we start to develop these projects, really looking closely at the communities that are going to be impacted and understanding, how communities are being disadvantaged in some way. And it's interesting with the screening tools right now. I think that we're still working out how to identify disadvantages based on those screening tools, because they're incomplete metrics right now. They're metrics that they're incomplete. So our approach has been to use the screening tool, but then also take account of the broader context. And I can speak more specifically to Wyoming communities, but we've been taking account of, well, a lot of these communities are kind of right on the edge of having a big dip in industries. Maybe if more mines close or if more power plants close, they're going to lose a lot of really good jobs and a lot of tax revenue. So really making sure that that is part of the story, part of the context that we're taking into account when thinking about social and environmental justice has been an approach that we've taken, and that's been well received so far. As we've been applying for those grant applications. And I do think it's really important that we look at the changes that are right on the horizon with these communities, especially coal communities in transition right now.
Okay, I would say to respond to that, I am actually out there saying, you are creating disproportionately impacted communities. Unfortunately, the data is a couple years behind. Unfortunately, we don't have the feds in the state that are evaluating all of these different regulations that are being put upon us. I was up until 10 o'clock last night writing a letter to BLM opposing a new plan that they're trying to do on our field offices in Grand Junction and the Colorado River Valley, reducing even more oil and gas production over there, and I am saying that we absolutely need to do a comprehensive economic impact analysis, and we need to start really weighing that. Do the benefits of, reducing these GHGs in this location, does that outweigh the economic benefits? Because when we're talking about GDP, when we're talking about jobs, I think a lot of times we're forgetting that these are people, these are families. And so, I'm out there saying it as much as I can. I'm trying to get their attention, and I'm going to continue to tout that message until they realize it.
Wait, girl. And I would just like to say, when you think about rules and regulations, instead of the state and federal government ruling and regulating us out of businesses and changing our quality way of life, maybe the narrative should be not only for the state of Colorado, but our federal government, is to remember that energy security equals national security. And the United States is in a way that we could be energy independent. And I think that's something that we got to continue to get out there, and maybe at the end of the day, maybe we can change it, but we can't do it by ourselves.
All right. Thank you both so much for being here today.
Thank you.
Thank you.
And then there's some of these brochures, if anybody wants one up here.
That was exceptionally informative. Our next session is an open session. I acknowledge that maybe not everybody in the room wants to sit and talk about what phase 2 funding, what the future of this project is like, as we're putting together our next proposals. I just wanted to thank everybody for taking the time today to be here, to be present in this conversation. I know everyone is insanely busy. It's meaningful to take your entire day to come and listen to us and have conversations with us. So I do appreciate that. For the open session, we inserted just some general questions here to get people thinking. These could be technical, non-technical. They could cover anything we went over today. If you think about these questions, we don't yet know what phase 2 will look like. The funding opportunity has not been announced from the U.S. Department of Energy. We anticipate it. The funding has been put in place at federal level for it. Phase 1, we conceived almost 3 years ago. A lot has changed in Wyoming and Colorado since we first put this project together. There are a lot of changes that have taken place to this project in that time period. We can say that phase 2 will be larger. It tends to upscale these funding opportunities. All of the CORSIAM groups had an opportunity to respond to an RFI, a request for information. All CORSIAM projects responded to the DOE with that. A lot of that is lessons learned. A lot of that is where we want to see these projects go. Current gaps, where did phase 1 miss the mark? Where should we focus phase 2 funding? We really can't write that proposal when we get there without input from all of our supporting partners and stakeholders and communities under this umbrella of the Greater Green River Basin. So this session really is just an open discussion. I think the first thing to talk about is throughout today, we've touched on a lot of different topic areas. And in those topic areas, where is it obvious that we haven't done enough? There.
Well, this goes against what you're doing, but we have these coal industries, and Ray said something that really flipped the trigger in my head. We're looking to diversify and transitioning, but I also think we need to focus and fight to keep what we need to keep a constant energy supply. We need to identify the things that we need our coal for, to make steel, to do these things, and that needs to be a piece of this. We don't just walk away, shut them down. We fight for what is going to be needed, or if there's a void there that can't be filled. Yep.
Yeah.
Exactly.
So in resource assessment, keeping track of traditional uses of coal alongside these novel uses.
For the nation, though, not just for us. It's for the nation. This is vital. If they shut these coal mines down, we're going to have blackouts. We're going to have all kinds of problems. They're not ready.
We are doing that. It's not always part of the CORSIAM project. It might get a lot of time a separate effort. That's why.
But we need to know that in our county so we can fight for that, because we have things in place now. Once you lose them, it's like the timber. Once you lose them, you're gone.
So we totally agree. I think one of the things we have to do is get you on our mailing list as our new publications come out. We're just about to launch our reliability series on the electric sector, and we'd really like to expand that as well. But we are doing that as well. It's just not part of the CORSIAM, and not sure the feds would fund it right now.
Well, they might not, but I mean, I think it's really important.
Yeah,
we can't just jump ahead before we're ready.
Yeah, I think those are both great points. So, CORSIAM really is specific to whole communities in transition, but standing up domestic supply chains and rare earths, or those things. So really looking at the non-fuel uses of coal. So CORSIAM really is focused on the novel use of coal. What I'm hearing is we need to do a better job at keeping track of those traditional uses of coal. Those directly affect how we may use coal in the future for non-thermal uses. So I see how we need to better communicate, keep track of those things in the CORSIAM project itself. Obviously, if we're doing economic prediction of future uses for coal in non-thermal markets, these carbon engineering things we talked about, we certainly have to think of the economics of thermal use of coal and traditional uses as well.
You're doing some tremendous work, and I agree wholeheartedly with what was said. We look at Joel, we look at all of the above, because there's no one size and one thing. Certainly, if we're looking at shutting down coal before we've determined what can be scaled up in a reasonable enough level where people earn average salaries, can afford that energy, we're going to be in a world of hurt. And I look at bread and butter issues. And we all know, and I'm frightened of closing a plant down, taking away a tax base, that is going to negatively impact the community and people's kind of quality of life. People come to communities for education, for work. When you've got no work, people are not going to move in. Then you lost your tax base. Then what happens to the colleges? What happens to small businesses and all of that? We believe that the legislation has gotten to a point where it is closing our plants down way too soon before we find alternatives. If there's some way of your work or you going to legislators or marketing a little bit better, the impact of some of these decisions on communities, that might help us a little bit, because it's hard when you've got one person, 2 people, 3 people, but if you've got multiple people, if you've got someone bringing the research there, that would be helpful as well.
And those are really good points. So I'll start one by saying we can't use federal dollars to lobby, but we can provide a lot of information and data through these projects to inform you on some of those pathways. And what I'm also hearing is, we've talked a lot about communities in transition and the decline of these communities as a loss of coal. And you're talking to community improvement, not just sustainability. You'd like to see these communities grow and not just try to grasp at what you still have. So future projects, all DOE projects include this community benefit. It's something like 20% of the project. That measures some of what you're talking about. But what I'm hearing here is working closely with you on those topics to better framework some of those arguments, and quite honestly, to collect the data.
And that would help in terms of framing the argument. That would be.
And one thing I've noticed in leading this project for the past 2 years is we don't have an economic piece. That stood out when we started this project, and it really stands out now. So we have the infrastructure business mapping you saw, and Christelle Cloth is an economist, but there's not a specific economy task to take a measure of this, to work in the communities and start to use that data. So Nathan Perry at Mesa State, we collaborated a little bit. He's done a great job at monitoring the local economies and accountants here, but we need a way to better integrate that into this project for both Wyoming and Colorado, and be able to make those economic assessments. Right. We'll go here first.
Yeah, so remember earlier when I mentioned the impact of the coal mine shutting down and traffic and the power plant shutting down? Our past county assessor put together a scenario. And he said, as an example, this was about 1.5 years ago. He said, the Walmart has an assessed, which we have here in Gray, has an assessed value of $2.4 million. The power plant's value is $168 million. So it would take 70 Walmarts to replace the power plant at that value. Or, as an example, Hampton Inn has an assessed value of $1.1 million, which would equate to about 147 big hotels. That is pretty in perspective, folks. I mean, that's huge. And so that's why this communications and this working with relationships, based across county lines and across state lines is so important, and changing the narrative as best we can.
Yeah. So, and I'm just predicting this. This goes back to that disclaimer slide I started with. We tend to see these large federal projects, these DOE-based projects, orient themselves in regional consortiums. There's been some language suggesting that right now we have 13 consortium projects, that some of the regional consortiums will work more closely together in certain aspects. I don't think we'll lose the individual identity of this project necessarily, but we'll start to develop overlaps with neighboring consortium projects. That's probably the unit to do. That's Powder River Basin, our other consortium project. Measuring impacts across those larger areas, but also measuring economic extent of these supply chains that we can potentially develop, I think is critical there. And what's most important there is how do we, and it's buried in these questions, who should be involved and at what level? how do we gain that information from, you know, the community of Craig, community in Northwest Colorado? And then if we're in these broader consortiums, you know, how do we include Eastern Utah? How do we include, you saw that there's 3 core CMs that overlap the state of Colorado. Who should we be talking to? We need to know that as we start to put this next proposal together. So we started with that slide of stakeholders and supporters. We need to like have 2 slides for that. We have a lot more people to move forward with this. And it's going to take input from everyone so that we know those people are. Some of what we presented is a little Wyoming centric. That's obviously where we're most comfortable, the University of Wyoming. But if we're reaching over state lines and these projects are dictated in these larger baseline areas, we need to. We'll go through.
Well, it is a tool. It's a regional economic model. Wyoming has that. It's a regional model that we use it on. We got the Rock Springs BLM to use it on where they do the economic impact. They just haven't updated it. But it takes a regional approach to economics. It's called revenue party of mine.
Okay.
It's the Department of Revenue.
And how did that relationship with BLM?
Well, they used it. They used the plan, which is 1.2. It's revenue. They just didn't update it in 2016 on the alternative they selected. So they didn't take current data and they just gave it to them for all of the alternatives. It's easier to use because you say if the BLM plan says you're gonna cut you're gonna take alternative being the conservation alternative and you're gonna cut 70% of the mineral production in the county.
I was just gonna say, in like Halloween was just a couple of days ago, and I went to a umpteen number of trunk or treat events and saw tons of people in costume. In all of that, I saw superheroes, I saw doctors, I saw, you know, all sorts of things. I did not see one miner. I did not see one construction worker. I didn't see truck drivers. You know, we're talking, this is the future generation of people that are gonna go to work. And I think it would behoove all of us to be a little more active in the elementary schools and middle schools about what mining is, about what the industry is, about what geology is, about what minerals are, simply because I would really like to see another geologist or a miner or a truck driver as somebody's future goal for a career, because right now, you know, it's just is future planning, maybe look at some sort of curriculum that could be in schools or some way to involve kids, you know, whether it's a summer camp, they take a tour of a mine, you know, whatever. Just some outreach along with your study to get future generations interested.
Yeah, that's a good point. I know Amy touched on it to start the education process more, of course.
It should start earlier. Sarah, I agree with you. It's gotta start earlier. Yeah, we talked about that too, kind of push it down more, especially the key buy aspect of it, because they don't know it and get them interested early, especially the science, the math, science.
You can tell a kid you can grow up and design apps that go and showcase minds instead of like design apps for gaming. Why not? I mean, it's the same thing, but one has an impact that's significantly better than the other.
So CNCC is currently involved in a project that's attempting to do just that.
Perfect.
So it's called Yampa Valley Partnership for Sustainability or Students and I forget the other S, it's S3. But basically we're looking at 3 pathways. So energy, agriculture and education. And the goal is to connect K through 12 districts with community colleges. So we're partnered with all the local K-12 districts and CMC and Steamboat. And one way that we're doing that exact thing that you're talking about is through summer exposureship opportunities for students. So this summer, we look to do some exposureship opportunities at our paleo dig site, which would have, get them out to the Sandwash Basin and actually see the geology and start to get into the vast area that is Moffett County.
And it's not hard to sell to get kids interested in dinosaurs.
Right.
I mean, they're there. So, you know, I mean, just the idea that when I grow up, I can be, just a princess. Yeah, let people know. Yeah, let people know. Let kids be involved in it, because the interest is already there. I mean, people play in the dirt. They want to be the
Yeah. There is.
Spin an afternoon at a power plant and bring them out.
And that's our second pathway is energy, and I can't assume that we would, I mean, I assume we would do that immediately. And the whole goal is like what you were talking about, let's get them introduced to it early, then get them in a middle school, early high school pathway through the K through 12 curriculum. And then concurrent enrollment comes in, junior, senior year, and we start to, send them back to you as apprenticeships or internship opportunities.
How's the current administration work?
What's that last part? Yeah.
How are they to work with?
Which one? We work with a lot of administration. Oh, yeah, and so, yeah, and that's an interesting part too, because it's the turnover is what kind of slows us down. But one way that we're trying to stabilize that is we have a board of control. So the board is the superintendents of Hayden, Steamboat, Moffett County, South Route, and then CMC and us. And so if that the board of control kind of sets the priorities, but then the steering committees are set up of high school principals, guidance counselors, and then our like concurrent enrollment director in that level. So really, we don't have to worry about, like, no offense, Dr. Jones, but the presidential level, because we're working in the middle management level of just building pathways.
And you get a good buy-in.
Yeah, and so really this project's not supposed to be full bore launch until next fall, but I think we're kind of accelerating some of those timetables because we're starting to gain some traction. I would say Moffett County is the least active in that work, but we'll get them there. They're new. They just got a new administration this year. Yeah. Yeah.
I was hoping they would.
So in this project, we do have a stakeholder outreach education plan that we have to complete in phase 1. And part of that is having ways to provide information for education purposes. One actual example I was surprised to learn about, the Kemmerer Mine has a program like you've talked about in the summer where they bring students in for a week at the Kemmerer Mine and do mine education with K-12 students. It's been incredibly popular at that point with that community. So it sounds like if we're looking at coals in new ways and under core CM, we need to also package that material for those types of programs and those types of age groups.
Think bigger than your local community. It's not a hard selling hammer to say, people minds them.
Right.
Kids know this is culture. It might be a harder sell for somewhere across the way. So what I mean is, let's look bigger. If you want people to care about what you're doing, you gotta show what you're doing.
And find common vernacular. Something that we've come across a few times is, because we work with the Steamboat crew a lot. And so, sustainability is a word we can all get behind. The ag ranchers, they have to be sustainable with their land. The coal mines have to be sustainable. Well, so does the ski hills. We can all get on that same vernacular. And so that you're right. It's education, it's communication, it's outreach. It's all that.
So do you have, or have you done research on kind of pros and cons of alternative forms of energy? If not coal, then, this or that. I mean, I hear that a lot. They're like, well, what would you recommend to you? That's not my background at all, obviously. And, but, is that something that when we look at this region, this area, some people say, oh, wind will work in this area of the country, but not in certain areas of the country and that sort of thing.
I feel like I'm going to toss that at Holly. That's a very broad question.
The question was like, can you say it for
more pros and cons of alternative forms of energy in lieu of coal?
Well, we would never do anything in lieu of coal.
Well, yeah, unfortunately, that's what we're being pushed to. So.
Yeah, I think that's a good point. I think at the end of the day, there's a lot of studies out there showing that. First of all, I would say one really important thing is to push back on this concept that wind and solar are cheaper, which is just completely accepted. And maybe that's true if they have, but it's not an apples to apples comparison because they're not 24/7 energy sources. And they need a lot of infrastructure. Like right now, the early wind and solar were able to plug into the grid in places where there was like extra capacity on line, well, like. That's not always where the resources, you know, we're gonna need to build new transmission lines, and building anything, it does not matter, anything is really hard. Because of NIMBYism, so, I think the issue is like, energy is really complicated, and to have a robust discussion is complicated, and it's easier to not do that, so. We haven't found the right path, quite frankly, to lead on that, so that's why we turn to things that are metrics based, like reliability. I like your idea of like, I mean, I think at the end of the day, you have to weigh the pros and cons of the choices you make. You know, just for example, one of the things we've done is when there was a moratorium on oil and gas leasing off federal land, well, that's some of the lowest greenhouse gas, especially our natural gas in Wyoming. That's a really low carbon footprint source of natural gas. And so we will do economic analysis studies, and that has made an impact. I mean, it definitely got picked up by the national level media. So there's like no silver bullet though. I honestly don't know, energy is just really complicated. And there is certainly this idea that you can switch out like a 24/7 energy source for when it's not, and that's just not right. I mean, you can't do it at low penetration levels, but if you see what's happening in Germany, already we know that you can't go as high as a lot of the models have shown. So, and that's, you know, we don't need to use models, we can see what's happening in Germany, actually Australia as well. So I was not really an answer, but just a lot of words. We're trying, we really are.
CLM has with their RMPs, they identify areas that are good for wind or solar. I don't believe they go into economics on any of them. I don't know. So, but they do identify areas that would be appropriate.
It sounds to me like that needs to be a regional focus in research. You know, a solar panel in one part of Colorado is not going to perform the same as it does 20 miles away in Wyoming. Wind on one side of Craig is different than the other side. Now that some of that infrastructure exists, and probably touching this, the economic assessment, they get there to look at that and now begin to see how these things do compare. But I think it seems very regional.
You go from your pilot stage on up, do they make estimates of the energy use needed to, I mean, it's an estimate. But
right. I mean, so part of the scale, I'm absolutely just consider that. That's right. That's what Trina had talked about with bench to pilot demonstration and becoming available for commercialization. There's a lot of lessons learned in each one of those steps.
I feel like there might be some powerful framing changes that we can leverage. So earlier you said it takes whatever 40 more months to replace this economic. Right? What does it take to replace the energy production? How many nuclear plants replace the coal mine? I don't. But that's a really easy thing to speed up. You know, how many solar panels make that replacement? Well, depends on where you are. So as we try to convey that information, if we can isolate ways that we can communicate that, maybe we can put, I mean, I'm coming from a visualization, but maybe we could put visualizations together to that end. Another thing I just want to say quickly is that I work with all the community colleges in Wyoming on this VR program we're putting together. And everyone, I mean, it's worked out really well, but a big part of that is getting community buy-in, going to each of the colleges, going to the high schools, going to whatever schools we can get into. It's a fun and engaging exercise to bring these emerging technology there. And I would say we should not diminish. If kids are getting into this stuff because they like gaming, let's lean into that. Seriously, gamification is like very human. I don't think we need to lean away from gamification. In fact, as playing in the sand pit can lead to working at mine, making games leads to developing meaningful apps. I just think we should leverage that.
Yeah, Kyle, one thing you should do is not only visualization on the energy side, but like the mineral side, because I'm trying to back and forth, seeing like where, if you build a wind turbine or a solar, like, and with the battery backup, where is all that stuff coming from? You know, and that can tie in maybe to Torsia trying to build some of those industries back here in the United States, where we're building up our communities instead of just like exporting our income and jobs to other places.
Yeah, yeah, that's very, very relevant to how we're trying to plan for regional supply chain development around Corsia. Absolutely.
Okay, legit, of course, this is something that lingers through my mind all the time, tied to the economics, tied to the supply chain. This kind of human rights and environmental side of actual rare earth element production that we will have to compete with. Do you anticipate that's even going to be addressed in possibly the next phase? Because if we can't ever compete economically because we have labor standards and environmental standards, what's the reality of this ever happening?
Well, that's a touchy subject.
Yeah,
That's for us. There's a few things we have to do in the technologies. We're evaluating regional placement, Corsia. Those things, some of those we presented on today, and some we'll recognize further go through our assessments. Those come with environmental health and safety document. So we have to understand the potential impacts for those technologies. We have to understand the cost of those technologies in terms of health and safety. The focus DOE really emphasizes is environmentally benign, is the word they use in phase 1. I don't think they'll use that in phase 2, environmental responsibility. So we're trying to look at pathways that utilize everything in the circuit. So if we're generating a carbon-based material for a battery anode, a graphite, the waste streams that come off that process, we have to understand what those are. What can they be used for? Not just identified as a waste stream, but what components of that waste stream are then usable for another development? That might be a rare earth extraction. If we're extracting the rare earth, we have to further refine it. What technologies do we have to use to refine that rare earth from an oxide to a reduced metal that are environmentally friendly? Part of that is going to be incentives, right? One reason we don't do this in the United States now is it's very processed to extract and separate rare earths. It's actually very difficult. And the timelines are very long. So you have to incentivize technology advancements to make them clean. You have to make it more affordable for both those of us researching technologies, but the private sector to step in and be successful at that. You have to consider, what those penalty costs are for the very last portion of that we may not be able to use. Yeah, it's a very broad question.
Yeah. So did you ever feel like when you were being asked for information, the other course students, do you feel like that's chattered?
Yes, I think so. I think the two big holes in the current phase of this project is the policy and the regulatory analysis side, and the technology price, the economic side, techno-economic side of this project. Those two were not written into phase 1. They were not required by DOE. We designed these tasks to start approaching those questions, but that was 3 years ago, and now those questions have to be asked now. So when we responded to that RFI, from that RFI, DOE will start to structure the next funding opportunity language. I believe every Corsium of the 13 talked about regulatory policy questions and economic questions around these. Quite frankly, if we don't start putting numbers around these concepts, they're not going to go in. Someone today mentioned at some point we have to pull the trigger on some of these things. We have criteria, we have this matrix to make those decisions on what we pull the trigger on, what we move forward with these non-thermal uses of coal. But it's going to take a lot of incentives. It's going to take a lot of review to decide what what those are. So I think we will see that. We're certainly anticipating. Big part of that is figuring out who we talk to regionally to help us with those tasks.
So, thinking on the end of policy and economics analysis, and thinking about incomes to the state. Does it, like, if you are mining coal to process for rare earths, how is the severance tax applied? Is it for mining coal for, really not thermal use? Does anyone know, what is the book mine?
I should probably sit down. So if we're mining coal, which is now, under a thermal coal lease, we're mining it for rare earths. What does the tax on that coal look like? Yeah, what's the outcome of that financially? I'm not even sure we can look at coal as a rare resource the way it's currently leased, so.
Well, I think it would be, right now under Wyoming law, 2%, Wyoming, 2% of the sales price. But.
Okay.
Yes. We can do a whole study. And the lease is not for rare earths, and that's another issue.
The lease is not for rare earths, that's right.
So that is another issue.
Right. Right, so we evaluate a full resource and a rare resource completely differently. From a regulatory standpoint. We have to figure that out. Well, that feels like a good stopping point unless we want to tackle any other questions. Yeah.
I just have a couple of pieces of information, so we don't leave as Debbie Downers about the coal industry or whatever. Current estimates are that the need for energy in the world will increase by 300% as of today in the next 20 years. So when you think about what 300% of energy use is right now, you think about it in 20 years, there's no answer that we have now to meet that energy use. Doesn't matter, everything we have right now is full board. We cannot meet that 300% increase in 20 years. So as you start thinking about, you talked about everything on the table and then that will be the direction, simply because people are consuming energy at such an intense rate. And it doesn't matter if you're plugging your car in, it doesn't matter if you're not plugging your car in, it doesn't matter if you're flying on free jets or if you're not flying. I mean, all of these things are things that we're moving toward. But the bottom line is energy is increasing, energy use, energy demand. So moving forward, talking about energy now, we don't know where we're going to be in 20 years to meet anything. We assume that it will be nuclear. We don't know what comes after nuclear, but I mean, all of the things that are on the table will be instituted.
Right, and to end on a positive note, these changes, and Ray talked about this, provide us a lot of opportunities. We should be excited to work on those opportunities. I really enjoy working on big, complex problems. So for me, this project and leading this particular effort is really, really interesting. I enjoy it a lot. I think we should be excited about solving this problem. So, yeah. Well, thank you so much for your participation.